We probably should have good food, more events, better speakers and all. And we have one volunteer who has been helping with us all those activities, Shadab. I'm not sure if he's here. Is he here? He's not. Yeah. So what is CNCF and what's the mission and the goal of the CNCF? Just to give you a brief. It's a non-profit organization, not tend to go on a direction of getting a profit or anything. And the main idea is to promote the cloud-native technologies. And one of the prominent technologies that you have known about is Kubernetes and Prometheus. Those are the main one which we have seen and heard about a lot. And the reason CNCF exists is to support these projects and create a community where we are contributing back to this open source project and keep the open source relevant and sustainable in foster. And lastly, when we talk about open source, the one thing that always comes to the mind is how we can provide a vendor-neutral home ground for people to talk and share knowledge across and build something for ourselves. So yeah, these are the four core principles and ideas where CNCF actually work on. And about this meetup started around Jan 2025, so I don't think we have made a lot of progress, but yeah, we are doing a little by little, and it takes a lot of effort. You have already seen in the WhatsApp group, people were asking about food. So yeah, it takes a lot of effort to answer such questions. But yeah, if you keep your questions relevant, I'm sure I can respond to you in 2 a.m. in the night as well. But I'm not sure I can give you answers whether you are going to get sabji puri or whatever. So yeah, and goal is to bring like-minded people who are probably working remotely or based out of Lucknow, or either they are in your, whether you are coming in your hometown for maybe 15 days or something, and so that you can also have the same space as the people who are working in Bangalore, in Hyderabad, in different locations. So you also get to experience the same knowledge despite you are not there. Like, we want to bring the same things over here, same community over here, so you don't feel the FOMO or think that, hey, everything is there in Bangalore, I need to move to the Bangalore. Why not bring things over here and basically learn about those? So that's the idea of this meetup, and I'm happy to see that we have 4 speakers joined us, and the talk titles are actually great, the idea is great. You will probably see if we can benefit out of those. One of the talk, or I think 2 of the talks are very high level. I'm not sure if you will to grasp it, but I hope you understand how these things are happening in the production. Those are real production use cases that we're going to see on this stage right now. And more about what cloud-native platform is. And recently I attended the KubeCon India that happened in Mumbai. And I presented over there our own CNCJ Lucknow meetup. Basically, you get a space to share about what CNCJ Lucknow is doing, whether we can connect more people who are from the same area. Okay. And we have been very active, not just doing these meetups since we have started a little late. But we are active. We have done some few community partnership with other communities like KCD New Delhi, and we are doing one more partnership with upcoming KCD Gujarat that is on the still right now happening. Once that is done, you should be able to get discount from the community. Yeah. So once that partnership is done, you should be able to get a discount, and you could join those events with some discount. And this is our last April meetup that happened. So we had Uchala give a talk on Anytech, how Anytech workflows and all those agentic things work. And this is what our virtual meetup that happened over the time in May. And if you want to be updated on what is happening in CNCF, you could follow those handles over the LinkedIn and Twitter. And there is a community page that you can join. So all the updates go via official channels. So and any event which is going to be published will probably first be reaching to the people who are joining to that chapter membership over the CNCG page. Now, this is not just one event as I thought, there are many events happening. These are a few other events happening. You can go there by submitting a scholarship. The CNCF provides a scholarship to attend these meetups or events which are happening across the world. So you can submit those scholarships and go there. Now we also expect people to share the idea they are working on, if they have something creative or anything they are working with right now and they think that can benefit other people and they want to open source. I think yesterday there was one guy who shared about one product and I wanted him to basically Astit presented that he created project around design, and I thought he could present that topic over here or the project over here that would have benefited how people are actually using different ideas, and basically we could see how people are building in our community in Lucknow right now. So yeah, we also look out for support. I'm not sure who are the people who are support us right now, but yeah, we have different ways you can support us, preventing speakers, slides, joining the event, and to join the group, you can just scan this QR code. Yeah. Now, we also have one more announcement to make, or few more things before I start the first talk. As I started in the event, let me go to the starting of the event. Yeah. So we have three supporters. One is the venue sponsor, which is InMobi, and two community sponsors, AI Community Lucknow and Ultimate AI. The Ultimate AI is sponsoring the t-shirt. For that, you will have to do some activity, right? Not just moving your body. You have to post on social, and if you are posting about CNCG Lucknow, what event on top or anything around CNCG, you should tag CNCG Lucknow handle on LinkedIn, or if you are posting on Twitter, you should tag that CNCG Lucknow handle over there as well. We will see whose posts are actually getting more traction, more engagement. Based on that, we'll give that ruling. We want people to notice that something is happening in CNCG Lucknow. That is the main aim from that. And what is Ultimate AI? I will talk about that as well. If I have some time in between, we will go over the demo, what this ruling actually does. Moving on to, I'm giving the mic to Prashant to talk about a little bit what InMobi is. And I think recently they did a IPO, or they are going for IPO, right? So yeah, InMobi is actually going for IPO, if I'm correct, right? That's the latest news that I've heard.
So hi guys, today I'm already taking a session and also representing InMobi. So dual role will kind of little bit extra for me, but I think
InMobi slides we need to put.
Someone should represent InMobi that is already older or already more experienced in InMobi than me. We have Abhiraj here. So Abhiraj, raise your hand and say hi.
Hey, hi guys.
Yeah.
Hello.
So he will be letting you know guys about the InMobi. What is InMobi? How many people already know what InMobi does?
Okay, no. So you guys know about InMobi because we told. For you, it's a revision session. For I'll going to tell you. As Avinash, He is Avinash, basically. So, as Prashant already told you about who we are and what we are doing over here. This is India's first unicorn, guys. So, we started at 207 or 2007, and at 2011 we become the first unicorn of India. Let's go with the stat, and our scale is our pride. So, the basic game, who we are an ad tech company, guys. What we are doing, we are throwing ads. We are B2B, that's why some of you guys don't know about InMobi, but in somehow we are in your phones. Might possible you are having Truecaller, might possible you go to Crippers, we are there and throwing you ads. You are using Hotstar, we are throwing you ads. So we are that buggers who throwing you ads. Yes. So this is our scales, guys. We are across 2.5 billion unique mobile networks and 2.5 billion, 250 billion ad requests per day, 350 billion impressions means click we have, and 6 billion data point processed and 8.9 petabyte of data we need. We have a cluster of it, and the biggest challenge, as Prashant already told you, we are having a competitor of Meta, Google. So they have their B2C business to customer like YouTube, Facebook, Instagram. For that, we introduced Glance. I told you who we are and what we are doing at Glance. So the biggest challenge is 50 milliseconds. In 50 milliseconds, we need to know what's your age group, what you like, and what you really need to get. And most probably, you click that ad. All that thing we need to do in 50 milliseconds. So, today, the world is a playground. There are around approx more than 20 offices globally. The stats is old. We are more than 2,300 InMobians worldwide. These are some of our stats in a smartphone for Glance, and these are some of our investors. But wait, how did we get here? It's all started with our co-founders, What If. They are having some tea and suggest that let's just start. And they just started this EdTech concept, and these are our investors. And why we are very motivated about Lucknow, because 3 of our InMobi and COE are from UP, 2 are from Lucknow, 1 is from Lucknow and 2 are from Kanpur. So we are really excited for this.
Yeah, I will add like 2 or 3 things back to the previous slide. What if? So that what if is, it's not just InMobi started randomly. They thought about first the idea. What if any Indian startup and produce Indian product or services throughout the global scale? Do we have this such a kind of companies that works across the globe? Very limited. And now in technology sector, like PCs and things are there, but for the product-based companies, we are talking about very limited number. And if we talk about the scale, yeah, it's very stark. So they thought about what if we start and get failed. No. What if one company from India or startup from India try to give the services and product throughout the global scale? What if India started producing enormous ad tech companies like Google, Meta, these are there, and we stood in a competition of them if we get paid? So these thoughts came and they started. And then started the team, next slide. The team they started, it's literally from UP, except one, but 3 guys from UP. One have done the graduation from Kanpur and one is from, I think, bachelor's from Lucknow, localized in Lucknow. So Mohit is from localized in Lucknow. So this is one example for you guys to take inspiration. You can start and go beyond what you can think of. If they guys can go that scale, you guys can also. You just need idea and things. Just wanted to add a little bit about inspiration from InMobi side. Please.
How we are contributing to ecosystem and how we are contributing to youth, how we are contributing to job market and how we are contributing to technologies. These slides perfectly showcase that we are providing jobs, we are having a first unicorn of India, we are motivating other tech unicorns to establish. I think one of you know about Miso. I think all of you know about Miso. Miso is one of our employee at Inmobi who started this concept and Inmobi supports that. There are more than 55 startups that drive from Inmobi and currently active. In total, we have 135 startups that Inmobi employees started, out of which 55 is established. That's what this slides mean. So, the future has arrived, guys. Nothing more.
So Inmobi made some disruptions in the market, and now it's a well-renowned company that recognized by the global global news sectors, and it got noticed. But you guys didn't notice. Get away with these details.
So, we are going to have Anchor 2026 if you guys are interested. It is for public or it's for okay, second round will going to be public just like a hackathon. If you guys are interested, it's a very big event we used to organize every year. It's a Pride and Core where engineers used to showcase their talent. If you want, you can put your submissions and take participations. Prashant, any comments on this? Again, what if?
So I've given some what if questions. What if we started, and then this what if become default for you all. Think like this default mode is for now for us. Inmobi is already moving, and they are taking some serious actions. They are very proud, and all the engineers they give same opportunity. What if you started and don't fail, or what if you start you fail? In both conditions, you will learn or you establish. So don't stop yourself. The same like ideology we set up inside our employees at Inmobi, and want to say same thing to you all guys as well. You have to start. We try to support, as we have already started supporting Lucknow, giving this talk at place and inviting you here and supporting other communities as well. So same thing, you guys have to think of it. We will support whatever is possible.
So, how many of you know about glands, guys, over here? How many use glands? Okay, the number are 3. Yeah? So, we started thinking why not make users lock screen platform where we can have some inputs. So, with this concept, guys, we introduced glands. One more concept of introducing glands is our major competitors are Meta and Google, and they are having their own B2C platform like YouTube, Facebook, Instagram. And Inmobi as a B2B company have to depend on some third-party platforms like Crickbuzz, Truecaller. Now we are having our own platform. Once our own platform got established, and we are having a good hit at US. 70% of the market at US. That's why some of our guys at India are not known about this Inmobi and glands. But believe me, guys, soon the boom will going to come. What we really do, the people who use glands, they know. So basically, the slides will happen. I'm going to tell you in a very simple way. The tier 3 people don't have exposure to good malls and complex. And most of the shopping experience from Myntra and online shopping applications were done by the tier 3 cities. And to overcome that things, we want a platform that people can have their instinct and know how this thing looks on them. With that concept, with that AI commerce, e-commerce concept, we enhance this app from lock screen to e-commerce and introduce AI and everything over here. So this is our app, guys. currently many of you know about the beer house company. Use their t-shirts. Go to their official website. Their official websites are showing glance, and you can use these things and put your what I can say recommendations. So this is technologies that we are using: LLM deployment, Android, hooking, big data, ML, everything. My prop moment. That's what I said. When Flipkart started, when Paytm started, we started at the same time, but we become the first unicorn of India, and we are the only company who become the multinational company as a startup, not Flipkart or Paytm, I can say. So if you want, you can scan this QR code. How any clothes looks like on you, it will going to tell you without you have to go to any shops and went there. So this is our goal and what we are doing right now. Thanks guys.
So thank you, Abhiraj. Abhiraj is serving as a IT guy in our company in Mumbai, and he is leading the Lucknow office for IT and security, cyber security only. And in movie and Glance is also coming in the market, share market, and launching their IPO. Anybody knows? So it's almost 1 billion evaluation they have put. Let's see. Market कैसे response करती है? And you guys surf about it. मुझे invest भी करना है. Okay, cool. So I request Sudhanshu, please take this session forward. And I think you guys are now excited कि हमारे पास ऐसा लखनऊ में प्लेटफॉर्म है. कई सारे जॉब ओपनिंग आती रहती हैं, आप कैरियर बोर्ड सर्च करिए एंड यू कैन अप्लाई फॉर दोस. अभी तुरंत करेंगे. It's okay. So it's like worth exploring because this company also give almost 23-24 LPA fresher package. ये बताना नहीं आता. Almost. I'm not being uncertain. I'm not saying this thing, but I'm just giving you a hint. You should prepare.
System makes sense to you, but not anyone else.
Hi everyone. So I see a lot of faces that I recognize here from previous talks. Hi. So yeah, today I'm going to talk about like why your cloud native system makes sense to you but not to anyone else. Does this title make any sense to you right now? Any idea? you are doing internship anywhere or have done it before? All are engineers here, right? किस
Yeah.
internship की है अभी तक?
आप लोग हाँ बता सकते हैं या फिर आप बोल सकते हैं जो भी लगे आपको you need to be active from both sides. Your little bit of body movement, little bit of speaking, maybe raising a hand, so we could see that you are still alive. You are not.
अभी तो पहला ही सेशन है.
Yeah, it's the first session. We should not see a hunger strike right now. We should see a hunger strike in between the breaks. Yeah.
Okay, तो चलो मैं बोलती हूँ. I am going to make a bold claim right now कि आपने जहाँ भी अभी तक internships करी हैं, I am sure you must have found a senior engineer or the engineers there tell you that ये थोड़ा कोड है, इसको आप टच नहीं करना, ये जैसे चल रहा है इसको चलने दो. Do you all relate to this?
Yes.
Okay, thank God you are right. So the same thing happened with me when I joined TCS Bangalore. I joined a US-based client. तो उन्होंने मुझे around 2 weeks दिया था कि देख लो डॉक्यूमेंट्स वगैरह पढ़ लो onboarding वगैरह. And then I was given a task to push something to production. So as a new employee, it was a big deal for me, right? कि आपको मुझे directly production में डालने के लिए बोल दिया है. I did everything on my part, but what happened was there was a few error which I was not able to understand कि error क्यों आ रहा है. I went through all the documentation again. उन लोग ने videos बनाए थे of everything. I went through all that again, but it didn't help me. So I went to a senior engineer. He was there for around 15 to 17 years. So his name was Yuvraj. So he took me to his desk and उन्होंने अपने डेस्कटॉप पे मुझे एक स्टिकी नोट दिखाया, उन्होंने चिपकाया रखा कि रन दिस SSH फाइल रन और कुछ है कोड है उसको कमेंट कर दो एंड ऑल, तो वो रन करेगा. पहले मेरे ज्वाइन करने से पहले अमित वहाँ पे कोई एम्प्लॉय थे सीनियर इंजीनियर, तो उन्होंने जो स्क्रिप्ट लिखी थी वो अभी भी चल रही है प्रोडक्शन पे, बट नोबडी नोज हाउ इट एक्चुअली वर्क्स. तो वो बस उस स्क्रिप्ट के बहाने चले जा रहे हैं कि ठीक है ये काम कर रहा है तो इसे करने दो, इसे छुओ नहीं. सो या दैट इज गोइंग टू बी द टॉक फॉर टुडे. या तो हम लोग आपके साथ ऐसा कभी हुआ है जैसे कोई सीनियर इंजीनियर ने कहा है कि ये छोड़ दो, इतना रहने दो, हम आपको और कुछ बताएंगे. Show of hands or something. Okay. So I'm not here to teach you all Kubernetes, and there are people in this room who are far better, more knowledgeable about Kubernetes and cloud native. I am going to teach about the problems I see in engineering teams from based on my experience of around 19 years. So so अभी एक एक्टिविटी करते हैं. So as our system became more evolved, we switched to cloud native engineering and Kubernetes. हमारा ये इंजीनियरिंग एंड अंडरस्टैंडिंग गैप थोड़ा बढ़ता रहा along with that. टेक्नोलॉजी वाइज हम इम्प्रूव होते रहे, बट व्हाट इंजीनियर्स एक्चुअली अंडरस्टैंड उसमें गैप बढ़ गया है. सो व्हाट हैपेंस इज कि अगर किसी तो एक सिनेरियो हम लोग लेते हैं कि किसी को डुप्लीकेट रिसिप्ट ईमेल्स जा रही है, तो व्हाट विल यू डू. लाइक कोई एक कोड है उससे बहुत सारे रिपीट ईमेल्स जा रही हैं, तो आप कहाँ पे उसे फिक्स करोगे? ऑर्डर्स में, पेमेंट्स में, ईमेल गेटवे में, नोटिफिकेशन सर्विसेज में, या और कहाँ पे आप फिक्स करोगे? ये एक रियल एग्जांपल मैं बता रही हूँ जो एक क्लाइंट के साथ हुआ है. Okay. So yeah, if you put like 4 senior engineers in the room and show them exactly the same problem, सबका अलग-अलग response आता है. So that is what is called the understanding bottleneck, and you can say cloud services as well or Kubernetes. तो this is what I was talking about कि हर इंजीनियर का इसमें अलग अलग आता है रिस्पॉन्स कि कहाँ पे प्रॉब्लम हो सकती है. So cloud native has actually identified this problem, and they have provided a platform where they can work on it and work on bridging the gap of understanding between engineers and the so we have successfully wrapped old tribal knowledge inside brand new Kubernetes YML files, and हम लोग अब easily 50 times a day code push कर सकते हैं. We have like built a complex modern city, you can say, of around 500 plus microservices, but हम उसे identify नहीं कर पाते हैं. जब जरूरत पड़ रही है, like where exactly to fix that code, वो हम लोग को नहीं पता चल पा रहा है. We optimize for machine execution, like on building, testing, deploying, and monitoring, वगैरह. But we have lost human application and discoverability. So what would be required to actually fix it? It's like time to autonomy. Like what is time to autonomy? Anyone here knows about it? नीचे साइड में लिखा है थोड़ा कुछ भी बोलो. एक भी थोड़ा जोर से.
The time it takes for a new engineer to confidently make a change.
Yeah. और पीछे भी किसी ने हाथ उठाया था.
अगर आप हाथ उठाए तो आपको माइक दे देता हूँ. आपके पास माइक दे दो.
Okay, so we are not giving time to autonomy the same attention as it deserves, apart from our regular coding and engineering work. So we track, like I said before in this week, we track like everything, like build, test, deploying, monitoring, but we don't track this metric, which is the most important along with it. So what happens is, when a new engineer joins, the expectation is day one, like or week one, they'll spend it on coding, then week 2 or day 2 and like pushing code to production or just referring to a senior engineer and then pushing it to production, and day 3 you are done, like you understand the system. But what happens in real is week 1 or week 2 already goes in understanding, requesting permissions to access files and everything. And yeah, by week 2 also you are waiting for client files access, understanding how the actual code works. If they have given you access to SDK, then understanding that as well. And you go to the Slack channel or whatever communication platform you use to understand how actually you can code, right? So that this is the reality, and actually cloud native services has already identified this, like I said before, and they have created a platform which can bridge this gap. And yeah, one more point I wanted to make. Like whenever a new engineer joins, they, as I said, like they will go to a senior engineer or who has been in that project for a while and continuously go and ask them questions, right? कि ये कैसे run होगा, अब मैं क्या करूँ and all that. तो cognitive load उन engineers का बढ़ जाता है. Like अगर कोई एक flow में काम कर रहा है senior engineer, आप अगर उसे ping करोगे तो वो flow छूट जाता है, right? तो उससे companies को बहुत effect होता है. There has been a survey वो मैं डालना भूल गई हूँ, but it so the same thing, like I said, like why relying on human search engines doesn't scale. So every single time someone has to DM a senior engineer कि ये कैसे करें and all that. So just asking them is, as your human documentation portal is a highly fragile organization structure. So what happens when your senior what will happen then? आपका वो काम रुक जाएगा ना थोड़ा सा, या टाइम लगेगा उसे करने में और ज़्यादा. So it increases mean time to recovery and burns out your senior engineer's talent. And this is an issue which not only I have seen, but all the big organizations have also seen. So now they are considering discoverability as an engineering problem. It is no longer treated as just a writing or documentation problem because its impact was huge. And big platforms like Spotify have also identified this and created a platform for it. They call it, they have built a platform called Backstage, which acknowledges these gaps and tries to reduce their time, reduce the mean time to recovery. So discoverability is, like I said, is engineering problem should be treated as that. So Spotify actually hit a wall when they had a lot of around more than 500 plus microservices, and engineers actually spent hours just trying to find simple API specifications. So they actually didn't host a documentation talk or writing and workshop. Instead, they treated that friction as a first-class engineering problem. Yeah, this is what I said. They can't find services or documentation. Earlier, the old way was asking in Slacks or Google Meets or wherever. So Spotify did this by building a developer portal called Spotify Backstage. It actually keeps everything under one click. It is like a unified phone book, making a service owner, API specs and dependencies discovered by default. So we actually stopped asking how to make infrastructure easier to operate and started asking how to make it easier to understand. And yeah, this is the same thing which I said before. A manual setup will take a lot of days, even weeks to understand from scratch. And because of Backstage and other platforms, I think Cloud Native provides the golden path. It takes a one-click service. It is secure, compliant, and monitored by default. So we, as a service-based company or also as a product-based company, we treat our clients as customers, right? But the companies we work for, they also are now increasingly making engineers their customers as well. So how is that happening? They have introduced something like developer experience. Have you heard about this term before? We have become world class at obsessing over customer experience, like our client's experience, but providing seamless one-click buy. But internal developers are customers of our own platform too, right? So right now, many internal platforms feel like they were made in the 90s. It's not as easy to use, and UX is not that good. So this is, I think InMovie is also working on this, right? I saw something like they have DevOps platform. They don't have that name, but yeah. So more and more companies are actually adopting this so that their employees become more and more, better at their work and their time to understand stuff pretty easily. So if the same thing, if internal developers cannot easily understand, navigate or adapt to your platform, they will bypass it. So if the internal user experiences is miserable, product delivery will be slow, right? So they will actively build complex workarounds around your platform instead of building with it. अगर आपको कोई चीज़ समझ में नहीं आ रही है तो या उसको समझने में बहुत ज़्यादा टाइम लग रहा है तो आप वर्कअराउंड ढूंढते हो उसके अराउंड, राइट? So So same thing was happening with internal engineers. So now developer experience is also taken care of, and it is given as much importance as any other client product. So I would request you all to learn more about developer experience. Yeah, so discovery is the real bottleneck in modern software delivery. We must optimize how easily human beings understand the systems they operate. So for that, phase one this is optimizing for machine execution, which is already taken care of. Right now, what happens is earlier we can say what happened was we spent more time in optimizing the software or how our software and product understands itself, right? So that the work execution is better. But now we optimize for how the engineers or employees or person, like how humans are able to understand the platform better, the machine better. So that is now needed. So phase one is that cloud native has solved how our code runs in production with human-made scale and automation. So this is solved. The next phase, like I said, is optimizing for human understanding. So we must shift our focus to optimizing how easily and effectively human beings understand, evolve and navigate the massive distributed systems they have built. So I would suggest you one thing. Some of you are doing internships right now, right? Is anyone working? So I would like for you to run a DM test this Monday. What it is imagine you are on a leave next week. Your cell phone is completely turned off and some issue has arrived and someone needs to make an urgent change to the system or the code that you have built. So if you disappear for a week, would production survive? Can any one of you confidently say yes or no? It will survive? Who is saying yes? So
like it will survive, I guess.
Hello. आप खड़े हो तुम देखिए. हाँ.
Like it will survive
How?
because like they will use AI to figure it out because even if I code I
AI की बात क्या नहीं हो रही है. This is internal development work.
even in that case like everyone uses AI so they can reduce
जैसे मैं आपको फिर से एक क्वेश्चन रिपीट करती हूँ. जैसे आपने कुछ कोड लिखा है वो प्रोडक्शन में अब रन कर रहा है बट एंड नाउ यू आर ऑन लीव. ठीक है, आप एक हफ्ते की लीव पे हो एंड समथिंग हैपेंस टू द कोड यू हैव रिटन. तो आपके जो टीम मेंबर्स हैं वो उसे रिजॉल्व कर पाएंगे या उन्हें आपको क्लीन करना पड़ेगा?
if they can if they will
Okay, so do you write comments along with your code or how will they be able to resolve it?
like if we make in my code base there is like a news.md file in which we update everything which we do. So like there is proper documentation and also whenever we ask our AI agent to write some code in every commit like the complete description is there. So if someone wants to do so they can do it log online and like read the commit message and they can understand what each commit is doing.
Okay, that's good. So if your answer was yes, so you have built a truly resilient, understandable system. So anybody else? Yeah.
If we have created a fallback function and clearly stated the error, then anyone can easily solve it. But without a fallback function, you have to go through the documentation and other things, and most probably reach out to me.
I think documentation is not, updated as frequently as you would have wished. अगर आपने अभी कुछ कोड पुश कर दिया है faster.
हेलो
Yeah.
लाइक मैं जो करंटली प्रोजेक्ट पर वर्क कर रहा हूँ, अगर मैं अभी एक वीक के ऑफ पे जाऊँ तो इट माइट बी कि अगर कोई दिक्कत आ जाए तो मुझे वो लोग कॉल करें, बिकॉज मैं सारी डॉक्यूमेंटेशन मेंटेन कर रहा हूँ, लाइक हम लोग खुद भी थोड़े एडिट से करवा रहे हैं, तो memo.md फाइल में अपडेट्स करवाते हैं, सर्विस पे
वो तो ऑटोमेटिकली अपडेट
लाइक हम लोग करवा रहे हैं, बट फिर भी अगर कुछ ऐसा बग्स आएगा जो कि वेबसाइट फट जाएगी या कुछ प्रोडक्शन इशू आएगा, देन दे विल गो।
तो that MRR so that would actually increase the mean time to recovery क्योंकि आपका कितना 2+ years experience होगा।
यस 1 टाइम।
हाँ, तो आपको ऑलरेडी कुछ सिस्टम्स आपको बाय डिफॉल्ट पता है कि ठीक है यहाँ पे ये चेंज करना है तो वो हो जाएगा, बट that's what my talk was about कि इसको हमको ये mean time to recovery को decrease करना है, right? तो इसके लिए the documentation that is good that every company maintains के documentation बना के रखना है, but we have to reduce dependency on senior engineers as well. तो उनके दिमाग में जो वो conditions वगैरह होता है ना कि ये कर देना है बस हो जाएगा, जो किसी और को नहीं पता होता है, तो there should be a platform like what I said, what Spotify has also identified कि वहाँ पे वो चीज़ एक सिस्टम की तरह, एक फोन बुक की तरह हो कि आपको कोई भी आया है कि बिलिंग में या स्टोरेज में इशू आ रहा है या कहीं पे भी, सो यू जस्ट गो लाइक अ गूगल सर्च उस पर और आपको उसका रिस्पॉन्स मिल जाए। तो या दैट वाज व्हाट आई वांटेड टू से। आपको भी कुछ बोलना था?
Only if the code base that we have worked on have multiple versions and error occurs, we can roll back for the time being while the team can fix.
बाकियों को भी पता चले कि आप क्या पूछ रहे हो।
Like it depends. If provided if the code has multiple versions, if the error has occurred in the latest version, you can simply roll back while the team works on the latest version. While fixing it, also you should have like proper commenting on each individual function as well as documentation. As well as if the documentation is like external library, you can cite that as well for further clarification. Also like keep proper document as well.
लाइक आई सेड डॉक्यूमेंटेशन तो उतना जल्दी नहीं होता है, आपका एमडी फाइल ऑटोमेटिकली अपडेट हो जाता है, कुछ केसेस में तो हो ही जाता है, तो या तो आपका आंसर इस पे क्या है?
So it will be yes.
It will be yes. Okay, great. यहाँ पे सबके सिस्टम्स ऑप्टिमाइज। Anyone else? जो इंटर्नशिप कर रहे हो भी बता सकता है।
जो भी सबसे ज़्यादा एक्टिव होगा, we have one T-shirt, the same one which I'm wearing as a giveaway, and I will be asking few more questions. Based on that, I will decide whom to give it. So you need to be active right now. I'm observing who is active.
Okay, चलो इस पे So this is about me. If you want to connect with me over LinkedIn, then you can scan this and connect. And if you have any questions, you can ask me right now, or I'm sitting here for some time. You can come and ask me questions. I basically work with I was an ex-developer at Bangalore in TCS for around 6-7 years. Then I switched to product communication. Now I work with startups on their product communication with engineering teams, and a little bit on the marketing side as well. So I help teams reduce friction between complex systems and humans. This is actually what I work on. So anybody has any idea like how this can be resolved or how this must have been resolved?
Can you repeat those questions so that people from the back can actually hear about if they cannot speak?
Okay, so are you able to hear me now? Okay. So what do you think? Like some products are really great, right? Mostly engineering products and everything, non-engineering as well. So why do great products still confuse users? इसी के बारे में बताया था.
Like if you are having a particular thing in a more technical way, so the normal user will not pay no attention to what it is. So it is the reason why the user will confuse. Further, if we talk about the engineers, then if we are having about code base and if in that it is not very well maintained, like if some function names are not very much relevant. So it will conflict with the engineers. And according to me, if we are having a particular AI and if we are adopting that, so it can make the terms in a very layman so that even our normal user can very much easier know about it.
Very apt response. So thank you. So what the same thing, like if you are someone who is a founder who is building a product, you know the inside out of that product, right? But if you are not able to convey it properly to your end user, like what's the main thing about the product you build, your end user will not be able to use it. अगर आप confusion में रख रहे हो कि ये product exactly करता क्या है, तो you will skip over. आजकल attention span वैसे भी बहुत कम है. अगर किसी को नहीं समझ में आ रहा है कि आपका product करता क्या है, तो you will skip over. So just one tip from my side on this कि आपने जो भी अगर आप कुछ भी आप product बना रहे हो, तो don't highlight the features of that product first. Highlight the actual problem that it solves. Features आप बाद में उसे आराम से बता सकते हो. The first, जैसे किसी को कोई भी इंसान आपके प्रोडक्ट को देख रहा है, if they are not able to understand कि करता क्या है, तो वो आगे बढ़ेगा ही नहीं. अगर उसे understand कर लिया कि this is the main thing point which I have and they are solving this, then they will be interested in knowing the features, right? Yeah. Mike? Sudash?
And another thing is that engineers love complexity.
Yeah.
Most of the time they try to over-engineer the things because, well, according to them it sounds good, it seems good. And this is the problem that it makes hard for layman to understand the problem.
कि जो इंसान उसी को कर रहा है, they are inside out of the problem. The main thing is making the user understand it. So yeah, that was somebody's raising hand.
Hi. So I think, like everyone stated, there is a complexity problem, but we need also to focus on the distribution part of it. I think most of the times when the product are built, mainly companies spend millions on distribution, and rather than making the influencer actually use the product, they are just simply paying them to advertise it. So I think the best would be to build, actually make some interactive marketing thing. So by that, users will actually get to know how the product is working, and they'll actually get to know the product inside out.
Yeah, that you are talking about marketing materials, right? Yeah, so before we create the marketing materials, we have to create, we can say like a documentation, like what exactly is the pain point that we are solving, first thing, and then how we are solving it. That will include the features and everything, and then like how they can subscribe to it and all that things. But the first thing, like I said, it should be the clarity. There should be clarity in what your product is actually doing. That will ignite interest, and then users will ask like, okay, how you are going to solve this. So that material marketing team can take, and then create accurate material and content and everything. And if that is resolved, then distribution of that material, then everyone will be able to easily understand what the product does. But yeah, like you said, like if the marketing material itself is not self-explanatory, you can say, or not clear.
It is not interactive enough.
Yeah.
It is just you are just pushing them to the eyes of the customer. You are not actually making them feel that you have the need to use this thing. So rather than just pushing them on you need to use this, you actually make them feel the why should be clear. So if the why is not.
Yeah. Okay. Thank you so much for it. Yeah. So that was my time. If you want to connect or ask questions, more questions, I'm sitting here for a while. You can ask and you can connect on LinkedIn with me. Yeah. Thank you for your time.
Thank you, Pranav, for giving a wonderful talk. I know it's a very interesting topic about the bottleneck and what are the things which should improve this opportunity and how we can improve the customer experience. So, can you guys hear my voice now?
Yes, sir. Yes, sir.
Okay. Yes, sir. Okay, good. Nice. So, I have about, I think, 3 questions to ask, and based on that, whoever gives those questions right, you have to get 3 questions right, not just one. And will they who's the faster? I don't think you can call it faster finger first. You have to raise your hand. Yeah. So these are very basic questions. If you have paid attention to the slide, I think you should be able to answer those questions. You don't need to explain all the details. So first question is, what is the full form of TDA? Whoever is the first hand. Oh, I see it there. You have to be fast. Can we give a mic to us? You have to get 3 questions right, not just one. Remember.
Time to autonomy.
Okay. First one is right. We have a second question. What do we mean by DevX and what's the full form?
Developer experience.
So see guys, I have told you, you have to raise your hand first, not just on the first question. We'll give chance to answer 3 questions to the person who has raised the first hand. That is why I said you need to be faster thinker first. See, you guys are not paying attention. Now the third question, what is the full form of MTTR?
TTR.
Yes. No guesses from back or anywhere. You don't know? Okay. No. You have to answer all those. Oh, you already know the answer. Then what I can do?
Yeah, me trying to recover it.
Okay. Do we have another question? Because that would be partially to her. Yes, we have a question for you. What is the platform name for DevX platform name which is Spotify created or open source?
Backstage.
Wait.
2 each.
2 each. There is a tie. We need one more question. Do you have a question which could actually break this tie off? You could ask the speaker right now.
Yeah.
No. If they see the slide, they will know the answer. Okay. This is more interesting. If slide to answer you. सुना होगा तो answer.
ये तो क्वेश्चन पूछ लिया है ना Spotify.
माइक थोड़ा और ऊपर करके बोलो. पीछे भी आवाज. See, बुढ़ीस के लिए कितना इंटरेस्टेड होता है ना. वो रीजन मेरा इतना ही है.
मैं वन सेंटेंस आंसर पूछ लेती हूँ ये स्लाइड के टाइटल्स
Do not answer, only raise your hand. Mic पहुंच जाएगा.
Whoever the faster finger first, not as in type.
In the beginning, like when I came, I asked this question: why a cloud-native system makes sense to you but not to anyone else? तो इसका आंसर है किसी के पास?
एक्चुअली एक्सपेंसिव हो सकता है। लाइक
गेम से बात
आपने कहा था जैसे कोई इंजीनियर है, सपोज वो एक लीक प्रैक्टिक तो जो उन्होंने कोड लिखा है तो उनको मतलब ज़्यादा इजीली समझ पाएंगे अगर उनकी दुनिया से इंजीनियर्स। दैट्स व्हाई ये बेटर है कि आपके लिए समझ आ रहा है बट आपके इंजीनियर्स के लिए।
तो हम लोग को क्या रिड्यूस करना है? फुल फॉर्म फ्यूचर का
मेन टाइम
time's up.
So we'll give a mic back to her. She also raised her hand.
Yes.
So yeah. Now you can answer. And it's talking around zero downtime allocation strategy. Yeah. Give us 1 minute. And you can give a introduction right away.
So yeah, before starting, I want to ask like how many of you know or using Kubernetes? Nice. Okay, cool. Yeah, so yeah, I so I can again. Okay. That's so okay. So a little introduction about myself. Hi, my name is Saurabh. I'm working as an SI, started already in May and improving. And it's been 7 years in space, in cloud and space, really. And today I will be sharing my experience about.
Yeah, you have the time for that.
So basically, we were talking about the order scaling. We know that Kubernetes is good at scaling, and it's basically a container orchestration platform where you basically do not need to worry about your underlying infrastructure. You just need to package your application and deploy there. right? And in a iterative way, you define your application requirements in simple YAML file, simply deployment there, deploy there, right? Now, the thing is, next comes the scaling. Next comes the scaling, right? How do you basically solve that problem? Because most of the time we have seen in our scenario, we're talking about my scenario, that we have around 20 plus clusters, and on average we have around 20-25 nodes in non-production. Mostly in production we have around 40 nodes. Now we have day-to-day operations going on. Right? Let's say we have AMI rotations, we have audit happening every day, right? So it's a quite, and SRE has to spend a lot of time, at least one sprint, to cover all this, right? And so we talk about the auto scale. When we have cluster auto scale, we have a carpenter, right? So cluster auto scaler is very simple, static. When you use Kubernetes for the first time, at some point in time, you might have installed it, right? Along with this controller. It's the first controller that you install on your Kubernetes, and it's good. It's really good. But what if you have more workloads, different kind of workloads in one cluster, right? So it actually operates on auto scaling load, and it's operate required nodes. Basically, if you know how many of you working on AWS, yeah, so you might know about the node rows and auto scaling rows, right? And it's a mature tool, by the way. But what if you have one cluster that has a different type of workload? I will give an example. You have entire runners, you have your application application pods are there. So both have a different life. One is short-lived, one is long-lived, right? Which will infinitely running. And these two different workload creates so much idle CPU and memories, right? And if you want to segregate them in different nodes, you have to create them and you have to manage them, right? Here comes the problem, right? So you have to manage them. Now let's talk about the AMI rotation we're talking about. Every month, if you have 20 different clusters and you have to do AMI rotation for them, it will be very tedious, right? So we had the automation in place. We had this hardcore workflow, the hardcore and hardcore projects there, right? So basically, it creates another node groups with updated EMI, right? And then updated Terraform. But the thing is, workload can range in between, and then you engineer as I have to go in between and rerun it, right? And Terraform is stable. It's status code. And wherever it is, the code is stable. It becomes a little tricky to handle, right? Here comes the Carpenter. Carpenter is open source tool. Both of them will actually answer the same question. Does cluster have enough capacity to handle the demand? Right? Both of them, but in a different way. Talk about little bit about why we migrating, right? So Carpenter is basically faster. Why? Because it directly all the EC2 API calls, right? So within a minute, within a second, it can provision a new node, right? Whereas in autoscaler, it actually mounts to autoscaler, but it's an extra layer, extra API call going on, right? And it's slow. And one very important thing, when you define your pod disruption budget, which is very important, specifically for your critical workload, and you don't want it to be disrupted. So you define pod disruption budget. But the thing is, autoscaler never care about it. So So if it's actually say that hey, I want to optimize the option, it will delete a node and you won't care about it. That node might be running your critical workload, right? That's the case with autoscaler, but Carpenter respected and it actually makes multiple instances, categories, generations, size, and it actually consolidate. Let's say consolidations you can assume it as a optimization of cost, time size of the nodes, right? And so if you see autoscaler optimizes it by deleting it. It's not actually replacing a cheaper node. So the carpenter knows about the AWS EC costing. So it knows what is the cost, right? And it says, okay, let's say you have a pod which requires 100 MB of your memory and CPU. It will check for that and it will find I have M6A X large is pretty much cheaper, right? And it will launch that rather than fixed capacity that we find in autoscaler. Right? In autoscaler, we say, okay, M6A.X X large, right? It will be there in that 2X large. It won't be replaced to the X large, reducing the cost. But Carpenter knows the cost for the AWS. Anything about what else about the Carpenter solving, what autoscaler might not be solving? Okay, now there are few people actually. Okay, now we know by using Carpenter, you might get an idea. Carpenter have more fine tuning over the autoscaler. You control more over the costing and node selections. Right? It's very important because right now, let's say if you running that much of clusters and you may wasting your CPU and memories. And now we have GPUs, right? You may be wasting that much. So we have to be very conscious about it. And we should be giving it in upcoming days. Carpenter already solved it, but let's see how it is. So let's talk about how Carpenter nodes are like how it actually monitor provision and optimize clusters. First is basically seeing the pending pods. Right? Let's say you have a new deployment going on, right? Then you see the new pod, Carpenter monitor the pod that cannot be scheduled by default Kubernetes scheduler, right? And it actually matches the specific request, resource request. Resource could be CPU, memory, GPU, and the storage, right? And then it also says the collaboration and demonstrate, so we find notebooks. Then it actually launch precise compute for you for your workload, which you call it node claim. In that, it actually directly calls the TCP API, and within a second, it actually provides your metadata on. And it creates now what is create the node? There is a continuous loop going on, which is called consolidation. It will keep looking into it, and let's say you have 400 pods running there. And that 100 pod can be accommodated in one cheaper node. It will do that. Whereas autoscaler has a static M6A, X large, let's say, but we have a range of them. We define MCR, your memory, optimized compute, optimized resource, optimized instance, and these are the two building parts. Basically, you can say the two basic configuration that you make to Carpenter work. One is node and one is node EC node class. basically node pool is equivalent to your node groups in autoscaler, right? It actually helps you to add constraint what Carpenter can launch. Let's say what is the architecture? You can have a ARM x86, right? Your aggravating quality indicators, and which you own it should launch it capacity type. AWS typically it's have two different capacity. One is spot and on-demand. Spot is basically you can say chunks that is AWS cloud giveaway and cheaper, but it actually do not guarantee the uptime. It can anytime read it back, so that's why it's cheaper. But and also what is the resource limit? In node groups, basically you find, let's say it should have around 5 node maximums, right? But in node pool, you decide how many CPUs, how much, let's say 200 CPUs, and memory is like 500 gig of memory should be there. On the other hand, digital node class, so basically as the AMI family, your storage and the subnet and security groups, so basically your storage and your networking.
Before we go on next slide, I'm going to can we ask any questions that you might ask the audience and I want to see how many people are actually.
Yeah, that's
you are the one you will not know. I would say you can ask the question.
Yeah.
Based on what you have talked so far.
Yeah. So how
you can go as deep as possible and as high level as you want. But if you want, I think we understand who that is.
So I would say, so like here people say that they are using Kubernetes, right? Like what's the how is this like right now? Should I show like?
What exactly the question is? What is the architecture? Basically, before that, I have a question regarding this side. Let's say we are using AFCs, right? The node groups. So, if any application needs storage, they will use EFS, right? So, for EFS, they need some security rules, right? To, let's say, any nodes get scaled up in that AFC. Like the security groups will automatically get attached to that edge. So how it is going to happen in Carpenter?
Yeah. So in this node class, there we have a tag selectors. Let's say you have a subnet tag, and in this node class you mention that tag. So automatically the node spinning up, that will go into that subnet. Right? So is that
SGs are related to the instances, right? It's not subnet level. It's like it's get attached to a particular instance. So my question is, let's say in Carpenter, when one new node comes up, one new instance comes up, so how it is getting attached to that particular instance? So you said it is going to be available for whole subnet, right? So if in that subnet any instance gets cleaned up, it will get the security groups will get attached. That's what I said.
Like in security group and subnets, usually it's tag based selector.
Okay.
So it will all the nodes will be selecting that.
Okay.
It will be in that.
So you were asking.
Yeah, I was asking how you would use cases, how you would handle it.
Okay. So we also manage with more than 60 clusters, EKS clusters. Yeah. So we have more than 80 plus applications which use Kubernetes, and for their high availability, they'll use whatever comes up with Kubernetes, the auto scaling command, use data or HPA. Apart from that, in EKS, they use this node groups. We are not using parameter, but yeah, it's good for like this.
So then, you also looking at adding CPUs, issues, and
yeah, we do, but I think this parameter it's very like precise in terms of resources utilization. But yeah, we are using this notebooks, ASGs. If they are,
yeah. So you might be having multiple notebooks for different workloads, right?
Yeah.
But that will be very tedious to monitor and
yeah, that is. Yeah, that's why I'm getting interested in this parameter thing because it's very easier to manage this in comparison to the
yeah, because it also looks for the cost.
Yeah.
We manage the cost and we can define the range of your instance. Let's say, and what the type of instance you are using?
It depends on the application. If they are using, maybe they want Grafton nodes. So I don't remember the specific instance name, but there are multiple types of application requirements. So,
right.
So
yeah. So and also, Carpenter can be helpful for like opting the spot instance. Why? Because it also gives us the introduction to spot introduction to. So basically how it works. So let's say you use spot but it's not reliable, right?
Like you don't use spot.
Yeah. So introduction is what it will do. It will give you 2 minutes heads up before it actually goes ready. So in that part, you can have a mix of the notebook. Maybe have spot and on demand, and by default, the Carpenter will use the theoretical spot. Now, if the spot is not there, it will fall back to the on demand.
So it's a reliability problem, right?
No, I'm saying you can still use spot in a reliable way because we are getting the introduction 2 minutes before it will steady. Yeah.
Regarding the price, which you said, the Carpenter, because it is a price also.
Yeah.
This is not one of the reliability problems also. Let's say to reduce the cost, it's using the lower instance rate. So won't it affect the efficiency of the application? If the resource constraint according to you never know like whether more requests comes in, right?
Yeah. So I mean, it will be respected in node request, obviously, but it will be optimizing node selection. So that's why we have to tune it in such a way that you don't either you have to really like choose between two like availability and costing, right? You have to be knowing your workload.
So if we are choosing availability,
yeah, it will be costing you. Let's say on demand. Right. So, but still you can up to some extent you can use spot in a more reliable way because Carpenter is already giving 2 minutes before terminating the node. So Carpenter is still the new internal resource.
We can, if you have any more questions, we can probably answer it after the session.
So this is not about just Carpenters everywhere, like in communities. So you might see the disruption, and it is very important to understand the type of disruption that we face. Because if we do not understand these two disruptions, we might say that Carpenter is not stable or it's not up to the mark, or you can say we might be taking it. We have seen when we were adopting, we have faced so many things because we saw a cost spike in one of the central cluster because our configuration was very constrained, our destruction budgets were very constrained. So it scaled, but then it was not scaling down because of those destruction constraints. So first is your volatility. it is always initiated by the carpenter and it is expected. So basically, during protection, so let's say your favorite AMI or your sleeping types or your different zones, and it actually detects it, and that also comes under the disruption. It will start breaking the news. And expiration, here, expire after 720 hours. So basically it's also a useful parameter where your node will cycle after 30 days. Because it's helpful because nodes might have uncached vulnerabilities there. You can reduce your workload, let's say 24 hours or something. Yeah, that also comes as a disruption. So it will also start pulling out the nodes. And but the good part is this voluntary disruption is really useful. It will give your pods access that node is going down. So pod will shut down gracefully, but the condition is your pod and your application code should be written in such a way. The signal termination and signal should be there. Right? The second is involuntary. It is like hardware failure, spot interruptions. It is something that we cannot control. And it is expected. And you cannot, in this case, you cannot be carpenter, right? This is what we are talking about, the disruptions, right? We can handle the disruptions, specifically the oriented disruption that is related by the carpenter to save the cost, right? Find a cheaper road and consolidate, right? So there are two consolidation policy. One is when empty and one is when empty or underutilized. Right? So when empty is basically remove the node only when once every pod is not there in one way, right? So it is where it fits actually. So you might have a batch policy, you might have a data branch, which will eventually empty the node. It will come and go. It's a shorter jobs. So I will just show you one scenario because of which we get our central cluster cost. So we were running both of these two different workload in one workload. So what happened? Let's say a data is on demand jobs. Someone building a data home by implementing that, or someone is actually doing some code. There is some features going on, and it will create a new product, right? And load keeps scaling up because of that. But we have a very high disruption budget. It says that okay, you can consolidate only 10% of the node, but there is a window. Like maybe in the morning you can only do that. Maybe you can downscale the window, sorry, the nodes in the midnight. So in this way, what happened is actually scaling 20-25 nodes, which was sitting there idle, right? And it was a problem. And in this case, we blame the carpenter, right? Because we set the disruption so concentrated, so restricted, it actually, not allow the node to be, downscaling, which is good, but we have to be aware of it. Now, so what we did is that, we created two separate node pools. One is when empty and one is when empty or when utilized. So, let's say we have pods coming up and when empty, diagram node pool is spot, which is very mentioned. So, one node came up, two different data pod came in and it gone. So, it marked as a penalty, so it marked penalty and simply removed. So, if you actually say the call there, right, you're not wasting so much time with it. And you can say that consolidate after, let's say it says mark it empty mode. After how much time you can terminate. That way you mention it. Okay, after 1 minute you can terminate. This way you mention like you give your volunteer progress. And then when I'm running like actually optimizing the cost and utilization will keep shifting. Let's say you cost there and it saves 8. You can save around 10-20% of the cost and it will shift to that. Yeah, now we'll talk about the migration part. We had guided interface. We were running the auto scale alongside the computer, right? And since it was very clear and it was not causing installations because we just removed the computer and it's not fixing doing the pending costs because auto scale is already was handling those scaling. Now, we actually reduced the control rate. Because we have to say that our nodes, right? Min, max, and that. And we actually reduce it let's say capacity was reduced significantly in small cells to result what happened is that load when we reduce it according all the load to costs per nodes. When we got it, we know that no input will be managed. Now, when load start reading, what get into pending state, right? And carpenter come to the action, right? And carpenter development and everything will go. And this is the loop that would be we were reducing the desired min max of the auto scale, right? And we already got it. And then carpenter will scale it. So you can see the shift from the auto scaler to carpenter. Now we didn't entirely remove the auto scaler because of the roll and pan. There can be virtually that may go wrong after migration. So what we did, like we scaled to 0 and we have this min max. Like max can be 1 and the other one can be 0. So in such way, we basically bypass the time consuming process where we have to reinstall it. Right? In such way, it migrated. Right? Yeah. So, any question for yeah, that's it. That's it.
Yeah. So, before we end this session, we again have one T-shirt out for grab and we have solutions. And now we'll again see who is a good listener and actually take attention, not passive listener. At least you would have Googled if you were listening to the session and actually hearing about the terms like carpenter and all of those things. Read a line. And thank you for Saurabh for giving this wonderful session. Hopefully, if you have listened to this session, you have learned something, but that was a very good one. And at least you have learned about what carpenter is and what the use case of the carpenter is, if you would want to use it. And we'll invite you over if I get disturbed while answering some of the questions. Yeah. So, one of the basic questions is which one of the cloud provider you are talking about throughout this talk? So, how would I make first thing of the first in this way? I will have to figure it out. Hands down. Hands down. So now what I will do is I will just randomly pick whoever I feel does not know.
Ask them to raise their hand and then you choose.
Yeah, I will choose. Please raise your hand. And I will see who does not know. I know he knows. He knows because he was saying in the last session that I know the answer. He probably knows in this session as well. You already asked the question, so you probably know about it and as well. She already got admission, so out. And that guy probably is the fastest fingers first, so I'm dicey on that guy. I see someone in the back. The one, I don't know, the आपके आगे. Yep, this one. No, पीछे. वो हाथ खड़ा है किसका? Yes.
Hello. The cloud provider is AWS.
Yes, it's AWS. That's the one we always go for. But does AWS provide spot instances, and what are spot instances? You have heard about AWS, but do you know what AWS does? Not does, as in we were talking about spot instances, right? We were talking about why we are using spot instances. Can you answer that? See, you need to listen.
Well, the session was about sport instances like EC2. Why there are mainly two types, the autoscaler and the carpenter.
You are creating the answer on the Okay. So that was a trick question. Who is the cloud provider? I just wanted to see who just heard the term AWS and raising their hands. Now, there is one last question, and I think that will be the nail in the coffin for this, and we'll find the right person to give this t-shirt to, and the worthy of this prize. So many questions. What is the benefit of carpenter? And what is carpenter? And is carpenter part of CNCF? Raise your hands. That guy always raise their hand.
So carpenter is basically a part of AWS which basically allows you.
Again, dude, you are creating the answer on the go. Are you?
I'm actually explaining carpenter.
Yeah, go ahead. Yeah.
So like carpenter is basically an efficient way through which you can expand the requirement according to your system. Like if your system requires EC2 instances and like engines, so carpenter allows you to do that efficiently. Like with maintaining cost cutting, and you can like do everything in a very optimized way.
We have the speaker over here. I think you didn't answer the other two questions, whether carpenter is part of CNCF or not.
So, I mean, the main benefit of carpenter is.
No, I'm not asking about the benefit of the carpenter. Is carpenter part of CNCF or not? Landscape. That's the very. See, can you give the mic to the person behind you?
Yes, sir.
Don't worry, we have more vision. Listen to the next session. Stay tuned.
It is an open source managed project, so it is cloud native. It is management.
Yeah, but we need to answer the first question as well. What is
so
carpenter and what's the use?
Sir already told. Carpenter basically helps with what I felt. Basically, it helps with the PDP. So it like the pod distribution project, it optimizes the costing that is gone because of the AWS, because AWS has certain constructs that we cannot like infiltrate, but like with the help of Carpenter, we can optimize the things in a more efficient way.
So I think he has an honest read on that one, the answer that we're getting about carpenter. And I think you're missing one important factor of the carpenter. And you have answered it's a part of the thing, not you are not answering me.
But I feel like AWS has like multiple dependencies. Carpenter just bridges that. Like, it itself is a tool for like managing your clusters in a more efficient way.
I think you were somewhere right, but there is one thing still learning that.
I might miss some like keyword, I think.
That's a very strong keyword. That's the whole gist of that session. And I think I'm letting him wait for that whole. Yeah. Where do we take the decision?
I knew you were before that. It was on the board.
We have some more people, we have further sessions. So free to answer. Qualification.
The two most important keywords that were used were that it is faster than the AWS platform and it uses better resource.
What is Carpenter?
Carpenter is a
So that was a very fundamental question of since we are talking about carpenter. That is why I'm focusing too much on getting the right answer. At least you get to get out something from this session. Yeah. Anybody else? Yes, we have one hand over there. We use the hand first this time.
Yes. So the mental basically is what is going on. That is the mental.
Carpenter is the orchestrator. Yeah. So you don't need to beat around the bush, you need to get it to the right point. And it is orchestrated. And I think we have been talking throughout this session about how it is orchestrated, why we are using it, and why all that, why it's for these things and all. If you have Googled about Carpenter, I think the first thing you would have heard about or read about is Carpenter is the orchestrator. Yeah. So yeah, we have a worthy candidate for this t-shirt. One more question. So we found a person, but yeah, he's declining. Now, I think the interesting part is what is autoscaler? Anybody else? Anybody else? You already know it. I know.
What is basically singing is a number of notes or chords or something. As well as the so always basically will scale your nodes on demand based on the requirements. So if more requests are coming or more resource demands are coming up, then it will analyze that based on the metrics and then to the signal more instances to work on. It's always automatically scaling up your
Doing it here and get excited whether you are your answer isn't real. We were not satisfied with that answer.
You can have one more later answer.
How are you doing? So, before we begin the talk, just a brief introduction about me. So, my name is Vijay. Thank you so much, Tanshu and Vijay, for inviting me for this session. And it's very amazing to see that cloud native is spreading its wing in my town, Lucknow, and thanks to everybody who is in the community who is making it possible. I've been involved with CNCF community for more than, okay. Am I audible better now? I guess. Okay, just let me know when I sound low. I feel low otherwise because of fever for a few days. So mind a little bit less energy today. But yeah, I've been involved with CNCF for almost like 5-6 years now. I've been a speaker at multiple QCons. But this is the first time I'm giving at a CNCF event in Lucknow. So this is a proud moment for me. So thank you again. So today we are going to talk about driftless, not AF that you might have thought of. The Gen Z is quite famous these days due to a lot of drifts, but today there would be no drifts probably. We're not going to talk about any other drift that we can see in software. So, yeah, I work as a senior software engineer at ChainGuard. So ChainGuard, how many of you have heard about ChainGuard? Anyone who wants to tell what ChainGuard is? Yeah, go ahead.
So, like in our organization, we use ChainGuard. We use Docker images, which is supported by ChainGuard. Whereas engineers, they stop the support for their images. So ChainGuard is the one who is giving us support.
Okay. Which company do you work for?
ADB.
Okay, nice. Good to know. So yeah, we basically are a supply chain security company. And what do we mean by supply chain security? When we mean about supply chain security, we mean about everything that you use on your day-to-day life to build your software. You probably would be referencing from open source. And most of it would be from CNCF files. Like CNCF is a massive ecosystem right now. If you are using even like any Go code, any library that most probably you are importing, is probably already able to contribute to CNCF. Now the problem with this is that most of the open source projects evolve so fast and are done mostly on a voluntary basis that it's very difficult to catch up with the drifts that they can take. And that problem is something that even we were facing while we were building our own software factory to solve the supply chain security problem. By supply chain security problem, I mean that most of you have pulled Docker container images. How many times have you observed that they had CVEs? Like in loads of CVEs. On an average, if you go and check upstream node image, it has more than 500, 400 CVEs. Now for a single organization, if it is using just one container image, it's fine. But if they are using hundreds and 200s of container images, maintaining them, patching them is a difficult task, and that's what ChainGuard solves by removing those vulnerabilities, not just from container images, but even from libraries, whether it's NPM or Python or Java. When we talk about Java, we talk about KVM, we talk about JavaScript, we talk about NPM as a package manager and pipeline for Python. Now, how are we able to scale this? That's why we built Driftless AF. It's an open source project which is based on Kubernetes vehicle silo pattern. I'm going to move it to the next slide to talk more. So, what's the agenda today? I think I more or less already briefed you a little bit about it, but the agenda today is that the first thing I'm going to talk about is the drift. Why system thinking? Why we have challenge while maintaining large number of software that is dependent on large number of projects. The other thing we are going to talk about is giving you a brief introduction about reconciliation. And if you have worked on Kubernetes project, you might be already familiar with that idea. But today I'm going to make it a simple analogy for you on how you can actually relate it in this room, how reconciliation works. And then we are going to talk about Driftless AF eventually, on what it does. And finally, I'm going to show you the proof at scale how it is solving the problems for ChainGuard itself and how it can solve your problems for you if you want to use it. And finally, the demo itself. So yeah, let's move finally, let you know about what is Drift. So how many of you stay in hostel? Like if you stay in hostel, I also stay in hostel. How many of your rooms get messy after a few days? I think every day. Every day. It's messy, right? How many of you actually care to clean it every day? Nobody, right? No, forget about hostel rooms. Forget about the software that you are maintaining. Like these kind of, psyche that we usually have as humans who procrastinate on these kind of maintenance work to catch up with the drifts. They also are carried over in software. And that's why that drift when gets messy in your software, it creates problems for people who want to actually contribute in future. For example, you contributed something new, right? But you did not update the docs. The docs are decayed now. Somebody was following older documentation and they cannot fix it. Conventions. For example, you are committing something. When you write, how many are aware about code commit conventions? Have you heard about commit conventions? Like if you are committing something on a project on GitHub, you usually have to follow some kind of convention. Like if there is a doc, you have to add docs/add, give it in brief, why there, why are you adding it? If you are adding a feature, you add FEAT field and then you add something about that project, right? So all these things are usually humans sometimes drift away from. They do not follow it. Probably because they are lazy, probably because of the speed that they want the software. No, we can rephrase this problem. Like we are now working with more than 700 people in our company. More than already $3.2 billion valuations. We have become at such a problematic scale in a good way that maintaining these kind of rates was very complicated. And why so? Because we have more than 2,000 unique images in our catalog. So what do we mean by images? So you usually pull your images from Docker, right? So in a similar way, just like Docker, there is StrainGuard's catalog as well. So if you Google right now, Node StrainGuard image, it will probably open up for you. Just search for Node StrainGuard image, and you will be able to see the number of vulnerabilities that upstream image has compared to us. Now Node is just one image. We have 2,000 such images in our catalog, including complex images like VLM OpenAI. Mind you, VLM OpenAI has usually 1,000 vulnerabilities, sometimes 1,500 vulnerabilities. Imagine maintaining these kind of projects. In the same way, we have hundreds of CV backports. Forget about hundreds of CVs. On an average, StrainGuard removes more than 10,000 CVs every day. Now that cannot be done. It's not possible to be done just by a human. That's why we have to build a factory. Something which can become agentic, which can reconcile on what we want, what kind of drifts that we do not want to happen. Enough of talking about drifts, let's talk more about the idea behind this reconciliation. Because even before we move to driftless, we need to understand what is reconciliation. So, most of you might have operated air conditioner, right? You set a temperature to something, like 24, 22, anything. As long as your temperature is not set to, as long as the temperature of the room is not reconciled to 24 degrees Celsius or to 22 degrees Celsius, the AC keeps on cooling, right? It keeps on cooling. Even if it is in outdoor mode, it will keep on cooling till it touches 22 or 24, whatever you have said. As long as it is met, it is waiting. It is not stopping, but it is waiting for the temperature to increase and it will again resume at the same speed or the same cold temperatures to flow started come back to the same state of 22 degrees Celsius. In the same way, reconcilers work. In fact, the entire Kubernetes architecture is based on this simple idea. So if you understand this, you probably even understood what Kubernetes does. And because our founders were also couple of our founders were also Kubernetes creators. So that's why they have followed a similar idea and similar pattern here. Now, as I mentioned, just like AC watches the temperature or perceives the temperature, in the same way, our software is getting watched by some state. Like it is being watched by probably an agent, probably by a work queue, probably by a dispatcher, and that watcher will actually observe what the current state is. And if it finds a drift between the current and the expected state, it will try to close the gap, and it will keep on repeating till it, as long as it is matching the expected state. Now, what is the benefit of this? Why this helps? So, the reason is that just take a look at example. For example, somebody has come to your home, okay, and there is no electricity, there is no inverter, and that person is very low will. Will you dare to respond to that doorbell? You won't, because you are not even hearing the doorbell. There is no electricity, there is no inverter, nothing is there, right? That's what we call in software event-driven architecture. So if you are listening for an event, you might miss it. You might even duplicate or fire it twice. It might get crashed between, and then there is nobody to look at what happened to that event unless you update observability, which you should. And this kind of drifts accumulates and keeps on accumulating. So this doorbell is a very good example of giving you a brief idea what is the difference between edge and state level. Now imagine if you have a secondary watcher on your gate, probably a guard, consider that guard. But that guard would have not missed that person, right? Because he is watching. He is watching on the gate that hey, somebody is here. Even if the event of the doorbell is wrong, that guard is watching on you. And that guard will tell you that hey, somebody has come, somebody is knocking on the door. Open it. Open it. And that's what the difference between edge and level-based architecture is. So this level-based is the foundation of reconciliation of any software that you want to take a look at. Now we enter the core Driftless AF that we want to talk about. What is Driftless AF for chain guard? So for chain guards, because we wanted to scale our factory, which we call factory, we wanted it to be done by agents rather than humans, or even simple services. We want agentic reconciliation, and that's why if you look at the AF here, it's not the traditional AF we follow, it's agentic framework. So Driftless AF. And when we talk about Driftless AF, let's try to briefly understand how does its architecture looks like. So currently, Driftless is based on two divisions that you can see. The first part is the infra part, which is the challenging part for probably any company or any organization that want to scale with agentic architecture. So our agentic architecture is again because of being level-based as we understood in the previous slide. What we do is that we have a work queue, reconciler, and dashboard module. And then we have the code Driftless code, which is basically the code that is responsible for executing your agents. Now we have support for both Google, Claude, and in a few days we will also have Codex executor as well. So this agentic foundation that you see, we have Claude and Gemini already has provided. Now what happens here? What happens here is that as soon as the infra receives an event or receives a trigger, it passes on the queue or it dispatches the service execution to this whole Driftless part that you see, the agentic foundation, and it is executed. Now how it is executed? How many of you have worked with skills? Claude skills. Have you heard about Claude skills? So if we are talking today, we are chatting today, if you even record my talk, and if you just put it to Claude and ask it to create it as a skill, it can probably do everything that I just shared here for you as whatever you wanted to do. That's why knowledge is the new code. Your knowledge base is the new code. And that's where skills come into play. So the second half that you see here, those executors are working on the skills that we have created to fix our problems. And I'll talk more in the next part where we dig into the architecture a bit more deeply. So if you go to a clinic, like most of you have been to a clinic, right? You get a token. That doctor might have given you a token. That this is your number, right? And you will only, no matter how many times you knock the door of the doctor, you will only go when you have that token entered in the queue. So the architecture of Driftless is something like this only. The trigger could be anything. In your case, in human case, the trigger is a token being called. Like the nurse is calling that just number aaya. Then you would be entering the doctor's room. In the similar way, in Driftless, the trigger could be a cron job or a GitHub webhook that could be created using a GitHub issue or GitHub PR, which you would be seeing in the demo soon, or a cloud image. As soon as the trigger is received, it enters the work queue, and the receiver accepts the token that you had. You give it to the nurse, which is the receiver. You enter the queue and you are dispatched to the doctor's door. This is basically the Go Code Plus agents. So that Go Code Plus agent is open source. You can Google Driftless here, and you can see how Claude and Gemini executors are functioning as of now, and how many bots we have, which are open source. There are a lot of bots that are also not open source. But the bots that we have open source, I am going to show you one of those bots in the demo shortly. So yeah, this is pretty much the architecture in a little bit more detail, but you can understand it easily with a PD token analogy. Now, if you hire in a team, you usually hire people with individual characteristics that they can do or excel at. In a similar way, agents have to be like that. You cannot do a one agent fit all for your software automation. You can do probably, when you are using Claude manually, you can run it like, hey, Claude, do this for me, Claude, do that for me. But in software, you require more control. Because there, the Claude will not know anything, any context, until unless you give it the skills or the permission to access those repositories. So that's why, as of now, we have these are some open source bots. So they will inspire violations against the standards that we have. Skill fixer, if there is a skill that is problematic or not working as it should be, one of our bots fixes those skills automatically. Auto fixer is something that I am going to show you today. Auto fixer fixes probably most of the things that are broken or need to be validated. Today I am going to shortly show you how auto fixer can be used. Log analyzer is something like sometimes when you are digging into an issue, the logs can be memorized. For example, even when I have to work, sometimes I have to dig through 2 gigabytes of logs. As a human, it's impossible. Even if it's possible, I think it's very turmoilic to just go through those logs. Log analyzer analyzes the logs, finds the exact place where the failure and correlates it with the place where it has an issue. That kind of agent we have it. And all of this build is using the same architecture that I showed you before. The Terraform infra and the Go code. And the Go code has, and all of this is also based on the skills. It's all skill based. There is no magic happening actually. Other than the code, of course, there is executable code. There is infra, which is the most complicated part probably here. But other than that, these bots are all based on skills. So yeah, I was talking about skills. So why skills? Because, for example, if your code base has some core standards that your developers are not following, or they are in a rush, they can create core standard recipe and make it part of one of our bots, probably validator or autofixer. So as soon as the autofixer detects that, hey, you are not following core skills, or this is not as per the core standard that we should have, there should not be what or want in the test, it will replace the code automatically with the core standards. Automatically. And fix it. And that's why skills are the core foundation for anything agentic that you want to do. And there is a very good blog by Anthropic on how to write skills or how to make your agents write skills. So a couple of them are like, skills should have progressive disclosure. Skills should never be greater than 500 lines in your markdown. If they are greater than 500 lines, most probably Claude will not be able to access it in one context sprint. So yeah, as of now, I think we have 100 plus skills in production already. And yeah, when we are talking about our factory, we also have a new bot coming up that auto-merges things. So most of our, 70% of the code that we write as of now or is just getting automatically created and almost automatically getting merged as well. Almost no human in the loop And that's because of just that simple code replace architecture. How? Because we have a maker-checker protocol. Like we have a confidence bot that checks how confident are we with respect to our standards, with respect to the security of the code that is being pushed, with respect to the protocol, the intent that it has to follow. And that is actually determined by that, and a gate has to be processed and passed on the thread. And if it does not pass that gate, if it is lower than the score that it has to be, then that PR will not be merged unless a human intervenes. So this is how ChainGuard is scaling because of this right now, these kind of mechanisms. And how it is helping us, I think we can already, I already told you, but more than 4,746 PRs opened by bots. And 75% of the lowest are auto-merged without human intervention. 75% of the PRs are auto-merged. And more than 100 skills are already in the production. And this shit looks easy, but this shit is hard. This is not at all easy. And that's why we thought of open sourcing with this, so that people who want to scale can actually use it, can actually learn from it, or if not, can get inspired by it. And now, enough of talking, let me show you a quick demo. If the demo cards are with me, hopefully it should work. So, yeah, let me show you one example. So, you all can look at this repository, right? It's a pretty blank repository. There is nothing in it. It's just a readme, right? Now I'm going to update this readme and create a PR without following the conventional commits, right? So what should happen? I will create a PR by adding the title as stuff and committing stuff. This stuff is like weird commit. Like what kind of commit is stuff? I'm updating readme. I should write a commit something like docs update readme, right? I will create a commit and PR with stuff, and I will add a label. So that label will be the trigger, that label will be the token. It will queue it in a Terraform module infra. And I will show you that in the Google Cloud Docs as well. And it will change it to the conventional commit automatically in few seconds. So let me do it right away. So this is this repository, right? I'm going to just add a few words like demo. And I'm going to add something like stuff added. Okay? And I'm creating a new brand because I want to create a PR. As of now, it's fine, right? Now I'm going to just create a pull request. I created it. If you look at it, the PR title right now is stuff added. Now I'm going to add that label, which is going to trigger the bot and the reflex architecture. So you can see this label, reflex autofix. This is the autofix bot that I talked about. As soon as I have added this label, let me show you the Google Cloud Docs. They should have been already triggered. You can see it is running, right? And it received some response. You can also check what kind of response it received. So you can see that this is the prompt that the code executor had. Please face the following PR relationships. And if you go and back and look at it, you can already see that this has been changed. I did not do anything. I did not even touch it. But this PR has a code convention commit and it has been observed in the logs as well. So this is just one example. We have a lot of bots that are doing insane stuff right now. But yeah, this is what I wanted to show. this is the small demo that I wanted to present. So yeah, thank you so much. I hope it was not that many.
You could probably ask them questions if you want.
Sure.
If you want to ask any questions to the audience, or if you have any questions.
If you all have any questions, I do not have any questions for you, but if you all have any questions, feel free to ask.
Yeah. In the meantime, let me finish.
Anyone questions?
Yeah.
So, I guess we don't have any questions.
We have.
We have? Oh.
Like you said about like AI factory, like can you please explain what it is and how, like for example, if someone wants to make it, so what tech stack should he follow to make it, like should he use ingest, LangChain, and what frameworks do you use to make these AI factories?
What I mean by a factory. Suppose you are in a factory, like a manual real factory, paper factory. How much manual effort happens in factory these days? Can you tell me? Hardly. Hardly. Like if you are
It's a collection of data from all the different sources which are coming, being stored at one place. More of them storage, the data is coming from different sources like your insights from clicking on a website. It could be any events which are being triggered, right, from interactions and apps. All those data is being stored at one place and later transformed in a more usable format. Then it can be used for analytics, what the user is doing, what the user journey is, what is happening, they can see the dashboard and basically generate business insight and decisions can be made. So that's what data warehouse is. And yeah, so to maintain all of these data warehouses, and there are data engineers who are building pipelines and all of those things, how the data should be ingested and stored into these warehouses. You do a data modeling, how you want your data to be stored in what format, right? And those data engineers have a very various tasks on a day-to-day basis. You are reading thousands of lines of models, skill query, figuring out where your whole pipeline of a data coming from one source to the destination and the breaking, right? And in code as well, you are writing a huge, you have a huge code base and you have multiple lines of code, and there's something broke down. It's very hard sometimes to figure it out. Now that we have Cloud Code, they can ingest your whole code as a source or a context, right? They know what is happening where in your source code. Similarly, in case of data, you need to understand where in the pipeline what is happening, where in your warehouse what is stored where, what table is where, what column is what. So that you know that somebody in the top of the line changed one column, now there was the pipeline in the bottom which is breaking. So you can see all of those impacts and things. And this ultimate code is more like Cloud Code for data engineering teams, and it is a customized RF. So how many people know about harness as a term? What does harness mean? Okay, one guy over there. 4 people, 5. Anybody else know what harness is? So you guys have created skills on Cloud Code. How many people have used the feature called skill in Cloud Code to create skills, agent workflows? Okay, you have used skills. You have created skills. Anybody else? So you guys are using Cloud Code but not creating any skills. That's right? Like, there were so many people who raised their hands. Okay. So skills is basically like do you have any kind of a task on a day-to-day basis that you want to perform? And let's say my day-to-day task is to basically check my mails and basically label them. I have a task where I want to label my all the mails in the morning that this is not important, this is very important, this is the financial information, this is the update, and all of those tasks can be automated, right? So instead of me going every time doing that thing or maybe asking a cloud to do it every time, I would rather document how I want my mail to be organized, right? I can do that and write it in a one file and store it away. So whenever I call that file, call as a context that hey, this is the task I want to do, can you read that and do it? This is what the skill means in a very basic term. You have some automated task which you can perform on a daily basis. You can pretty much store it and write it away that this is the task, and basically you can call the cloud and do it. So yeah. So that skill that you have created is like a harness. It's a one piece of the harness. Basically, the Cloud Code itself is not that intelligent to understand how you want your things to be done. You have to tell it. You have to make it understand what you want to do with the data or the repository that you have running on. So you build toolings, and if you see as a human, like ourselves, our brain is a Cloud Code, right? Our brain is like a Cloud Code which has access to the LLM, or basically or conscious or cognitive. But these hands, legs, fingers and all of those are harnessed, basically making you possible to do something which your mind is saying. In the same way, Cloud Code has a mind connection to the LLM, but to make it work, have access to your file, access to your Chrome, different tabs, and all those details are basically our tools built into Cloud Code. Similarly, Ultimate Code is creating more like hands for data engineering team. So it's more like customized tooling for data engineering team that they need. Basically building inbuilt capabilities for data engineering teams on a day-to-day basis. And those will come pre-packaged. Like we are adding hands to your own LLM, that to customize for a data use cases. So one of the quick use case I will show you is that you can discover how many models you have, or MCPs that you have on your server, or basically if you have a DBT project or you have been using DBT project, I'm not sure if you are using, but it can pretty much automatically see what DBT project you are using, and based on that, it can take further decisions and call, and always try to answer around that. Basically, it won't steer away or drift away. I think the similar thing which we talked about, not at the exact time, but model to drift away from what you are asking and giving a different response. To keep them centric to the goal, you can give them more additional context so they are more grounded to what you're trying to basically ask. So once I run this, it should find all the things that are running in this one. So it will run a skill called discover and try to see what this repository has, what project is using, what warehouse connection it has, and based on that it will build a context that can be used for further tasks. So this capability of discover is like harness, right? And which is allowing that ultimate tool to understand how your DBT project is configured. DBT as a project allows you to do what? Data modeling. You guys know what data modeling? Data modeling, what do you mean by data modeling? Can you guys raise a hand if you know about data modeling at all? Oh, one person over there. So quite a few people. Basically, how you want your data to look like. So as I think the guy said, data comes in a very noise form, and to segregate or basically filter it out into much more usable format, you have to model it. You have to design it in how your data should be entered into final state. To do that, there is a tool called DBT. DBT has projects in it, and within that project, you connect to that warehouse where you have stored your data. And modeling of how you want that data to be modeled is done via SQL query. Like this is the table, this is the source, this is how I want my destination table to look like, or where I'm putting my data in. So all of this is done by DBT. And DBT works in a space of ELT and ELT, I think? ELT. Yeah, ELT. Extract, load, transform. You have heard about ELT? ETL. No. ETL is there, but difference of how the process you want.
ETL is just extract and extract on extracting and loading it. DBT is more on a transformation side.
Yes, more on the transformation. So in the whole process of ELT or ETL, it's a transformation layer. How your data to be transformed in what format. So it will scan through your repository. So every time whenever you run a DBT project, it runs on a code repository or basically a git. So it reads all the details which are configured, and then we will figure it out how I need to answer. So if you see, it's been asking questions, it's similar to how you run cloud code. And once it is done, it will see what needs to be done. So it has find out that there is a need for a DBT connection to be added and all of that. But to come to this decision, basically, even to ask a very specific question about the DBT project, that hey, you have a missing connection, right? Should I go ahead and add it into profiles.yaml? That question, I don't think right away Plot will ask. Plot will probably drift away, go around doing. You have to put that context into that messaging. That hey, this is a DBT project, you need to do this, you have to do that. Then you are building that brain for that Plot to understand what is happening in the repository. But for ultimate code, it's like day one thing. I know what data projects are, I know what is happening in the data space, and pretty much I can understand what is happening. So you will probably gonna ask a very relevant question to me rather than just stating away. That is what ultimate code does. I'm not gonna go too deep, otherwise since a lot of people already does not know about DBT, otherwise you'll be lost in a translation kind of a thing. Cool. And it has built-in skill, so I will just want to go over the skill thing. That should be straightforward. So if you see, DBT has a lot of things in it. So do you guys know what PII? Anybody who answers the PII full form, I will give away the t-shirt right away. Apart from this guy. What is the full form of PII in data field? एटलीस्ट इंटरनेट वर्क करता है, ठीक है. फास्टेस्ट फिंगर फर्स्ट. अरे रुको तो. सो भाई मित्रजन एक बार देखना कौन किसका हाथ सबसे ऊपर आता है. लेट मी नो. एंड मुझे पता है कोई ना कोई पीछे से ही आएगा. 1 2 3. भाई पीछे से भाई. Next time we'll have that will be good. क्या बोलूँ मैं But you have to click that button.
personal identifiable information.
But what it is? फुल फॉर्म तो आपने बताई है, पर अब क्या है ये तो बताओ, आपने गूगल तो किया? ये तो वही हो गया कि आंसर मैंने कर दिया है, इट्स नाउ ऑन यू, यू हैव टू फिगर इट आउट, आई हैव डन माय जॉब.
So, for storing them into a database, like personal information, like name, credentials, or like how do we identify that person on the basis of details? So that is what.
More or less right answer. Your email ID, your Aadhaar number, all of those details are basically PII and cannot be stored right away or cannot be shown to the analytics or the person who are creating your dashboard or present to your end user may be exposed right like that. We have a lot of policies and compliances to follow, so we have to mask all of the details. That is where PII comes in, and that is where we do PII audits. And every time we do data transformation, data related work, we have to be sure that this is not going anywhere wrong. So yeah. So all of these skills are built in, and that is where this tool actually helps. Not just that, I don't think anybody have just raise your hand if you have heard about lineage. Lineage. See, this is the one guy who knows about lineage. Lineage. Anybody? Lineage. I don't know you know. Lineage? No. Okay. Well, I will sum up from like you can come forward and take a picture. Yeah. You have been raising hands so many times. Make sense to you now. Okay. Yeah. And not just the lineage, SQL queries, other details are also there. 500. Yes, can you come forward over here and give the t-shirt and may I know your name? Abhinav. Yeah. Yes. Now, this is where we'll have to ask you to come over again. Yes, to give away the beneficial, basically, to being a very wonderful speaker today. Good. And we have something to do. Yeah. Cool. Thank you. Yeah, now coming up on this group session. I think we are all done. We have one more talk left. I'm going to just put it here and let you guys go to read all the data and see if that makes anywhere in your journey before actually getting into yeah. So for the next talk, we have Prashant. We have Prashant Shukla from AOP.
नहीं परफॉर्म मिल जाएंगे.
To talk about where LLM lives and how they get scaled on Kubernetes and how we handle it as well.
डेड हो गया एक होगा ना बताएंगे
This is the extension. This is the extension.
We almost I have 17 minutes lost. 2 बजे सेशन खत्म हो जाता है. So okay. So before you decide, I would like to explain a bit. It's fine. Audible to the end? Yes. Okay. Cool. So before explaining. You already gone through the talks and people have told about कि agent होता है, skill होती है, ये सारी चीजें काम किसके पे कर रही हैं? Of course, LLMs पे, right? So where does this LLM live? Anyone can respond? Yes, please. Mike. You have voice.
LLM lives basically in cloud or in your hardware and also on edge devices. Like in cloud, when we call the API, it responds, so it lives on the cloud. It physically do not exist.
Exactly. So talk is over. That was the only talk. But can anyone explain the journey how this LLM runs in the cloud, how these Kubernetes clusters manage this to respond to you? Same, you can respond?
So these language model basically learns from the large database, basically, and when it is held in the cloud, it stores all type of information that we have given to it by fine tuning. And when we call the API, like for example, we are taking ChatGPT. It has free API, and when we call it, the server connect our customer to that model. API is just like a doorway, and when we get the key, we can access on the cloud and we can get the information which we needed.
Okay, cool. So that's almost correct. But these LLMs are equal to similar to your applications, that web applications or normal application you deployed on the cloud cluster, or behave similarly, or they share same memory strategy that Kubernetes do the scaling. Same. Anybody sure? Yes or no? Same, share same infra, same configurations? Okay. So, no worries. I will walk you through not just LLM, how they live on the infra, not just your cloud, not just your own infra, but I will show you how these LLMs actually work behind the screen in the background with the infra. So this is not just a talk about LLM, how they work. I'm not going to cover it. You already have seen the talks or the things. How many knows LLM how works? Just roughly idea having. Just raise your hands. Thoda energy down here, but keep cope up with me. I will finish this talk early. So raise your hand. How many of you knows? अगर नहीं जानता तो मैं deep में जाऊँगा फिर. I will explain each and every bit. How many of not knowing LLM work? आप यूज कर रहे हो, क्लाउड यूज कर रहे हो, चैट जीपीटी यूज कर रहे हो, बट नॉट नोइंग हाउ दे वर्क. Raise your hand. So, दोनों में हाथ नहीं उठा रहे. पता भी है नहीं भी पता. What I should understand from you guys? पता किसको पता है? Raise your hand. कि how LLM works. और किसको नहीं पता है? अभी भी बाकी के लोग बाकी. See, I will not go to the next slide if I not get my answers. So you have to be struggling with me. अगर मजा नहीं आ रहा है, जाना है तो बता दो.
And one more thing, there are still 2 t-shirts there.
वो लालच है. वो मुंह में है, पता नहीं जाएगा.
So I didn't give it in mic because I wanted to give it in his session. Because his session is actually more important. And talks on the line of where LLM lives, which is connected to the same where ultimate code how it moves. So his talk has some leverage.
Yeah. So basically, my goal is to give you some insights about the LLM, how they work. It's about you should understand whatever you are using every day for making your life easier in a development and prod environment. Rather than as a student, also it should help in your prod or future goals as an engineer. So let's see how many of you knows who I am. My name. सुबह से शाम तक इवेंट कराते हुए हो गया. अभी तक नाम ही नहीं पता. अरे रॉन्ग टाइम पे ये भी नहीं चला. स्लाइड्स चलो कोई. सारी बटनें एक साथ काम करने लगी. Okay, so manually. Yeah. It's working fine. Oh, we debugged. Developers glitch. Production में कुछ ना कुछ जरूर फटेगा. ये फट गया. Okay, so this is me. My name is Prashant Shukla. I am working as an applied AI engineer, having 8 years of experience working in the same domain. My niche is image processing and agentic AI or something. But I also am organizer of Lucknow AI Labs. That is working around 3 years, and I'm like focusing on helping all the people in Lucknow to improve the tech ecosystem. Whether you are a student, whether you are a startup or anybody. Anyways, I can help, like I try to figure out how I can help you to grow in this ecosystem, because my vision is to grow the whole entire Lucknow ecosystem as a tech. So that's Lucknow AI Labs. And again, this me is behaving. चलो ठीक है, थोड़ा सा मैनुअल एफर्ट कर लेते हैं। वो लगता है कि स्लाइड्स ऑटोमेट हो गई हैं, उनके पास भी अपना ऑटोमेशन आ गया है, मुझे बीच की स्लाइड्स नहीं प्रेजेंट करने देंगे। ओके, लेट्स फाइन। सो 2 seconds ऑफ मैजिक, वी विल, एवरीवन नोज कि हमने क्वेरी की, हमें रिस्पॉन्स मिला, दैट वी डिस्कस, राइट? कि LLM के पास वी हैड डन द क्वेरी, API गेटवे के थ्रू LLM के पास गया, डिस्कशन LLM ने कैलकुलेट किया और हमें आंसर दे दिया। So today we will try to understand step by step ki how this LLM is actually big and working behind the bars, and also how you can train it or how the big giants have trained it. These questions you will get to understand. अगर आप लोग पहले से जानते हो, raise your hand. You know how OpenAI trains their own models or Llama trained?
A bit.
Yeah, that's great. So he will be helping out throughout the session now. Okay, so it serves million people. Next slide. Simple. We are using the prompts, doing everything and getting all of the types of output, content generation, summarization, classification. Many people have written the poems if they are interested. Some cognitive generations and these kind of activities we do. So how this LLM works? They just do calculate the next token. It's a very sequential. How like any model that is too big, 405 billion parameter model or any 5 billion or 7 billion, 3 billion parameter model, they all work in the same direction, same way, just predicting next token. मशीन कितनी भी बड़ी हो, एक ही काम कर रही है, सिर्फ नेक्स्ट टोकन प्रेडिक्ट कर रही है। So with the probability, here is the example how they predict. मैं थोड़ा सा fast forward कर रहा हूँ. This is the summary of how LLM works. You guys can understand how it works, or should I explain? जल्दी आंसर करोगे, मैं जल्दी आगे बढ़ूँगा। बताओ किसको इसका एक्सप्लेनेशन चाहिए कि what is it? Okay, good. So basically, the input is going. What second step happens? It's a whole LLM journey. It's not like OpenAI का LLM अलग है, इसका अलग है. This is a kind of a transformer how they work. जो भी tagging है वो इस तरीके से कि how they trained, how what their data have, the what infra they have used, how they which kind of data and what kind of a subject output they had fixed it. ये सब differential parameters हैं different. मतलब cloud code अगर आप use कर रहे हो तो वो coding parameter पे उनका एक opus model या फिर इस तरह से training हुआ या फिर आप GitHub Copilot use कर रहे हो तो that is mostly trained on the data of programming scripts, languages, GitHub repos. अगर कोई मॉडल अगर आपका ट्रेन हुआ है जेनरिक इंफॉर्मेशंस पे लाइक न्यूज़ एंड ऑल, आप उससे कभी पोएम नहीं लिखवा सकते. आप लिखवाओगे तो वो भी उसमें भी न्यूज़ घुसा देगा. That happens. So these are the kind of things that matters. अभी दिख रहा क्लियर? किसी को नहीं दिख रहा? पहले बोला था. Okay, so third step is converting into the embedding. मैं बहुत ज़्यादा डीप नहीं जाऊँगा because this is will be the out of scope of today's talk. But I will just definitely want to make you understand how they work. The third step is always the embedding, converting into the tokens into the embedding. Then LLM, the brain, the transformer, who all knows attention, all you need. Forget usually the names. So the paper published by Google team, the same thing they had launched, like first transformer model in a working condition with attentions. That takes your input, generate key value query. Remember this term, I will reuse in next slides. So they use this and after that the calculation happens, prediction happens, decoding is we are discussing the capital of France is Paris. So that is the recoding part, predicting the next token. Next is the final output, that is you receive. So this is what happens in the behind. Next. And everyone can see how many parameters increase over the time. What is parameter? You are responding every time. I want someone else now. What is parameter? So, okay.
Parameters are just like the knobs in the like program. If I have to give example, more the parameter, more accurate answer I get. Like in a Siri, it has over 8 billion parameters. It will give more accurate answer as compared to our Google system.
Great. Correct. So these parameters over the time, like ChatGPT 4.5 have 1.8 trillion parameters. What it mean actually? Or Llama have 7 billion or 70 billion parameters. Do you have any idea like what does this mean? Or is the generic term parameter? So let's see. Now it going to help on me. Yes, it's helping a little bit now. So imagine a music studio mixing desk, hundreds of knobs there. किसी ने देखा नहीं? एकदम बढ़िया से जॉकी टाइप का होता है, वहाँ पे मिक्सिंग कर रहे हैं म्यूजिक की, डीजे चला रहे हैं. Something like this, hundreds of knobs only. This is parameter. हर एक knob parameter है, जिसको ट्विस्ट करके म्यूजिक को चेंज कर सकते हैं, उसकी बेस को चेंज कर सकते हैं, ट्रबल चेंज कर सकते हैं. सेम वे में जब हम बात करते हैं मॉडल्स की, सो चाहे वो 8 बिलियन और 70 बिलियन 405 बिलियन, दैट मीन्स दिस मच knobs are there that you can tweak and twist to fine tune or train the model. अभी कोई किसी को कंफ्यूजन की नॉब क्या है या फिर पैरामीटर क्या है? अंडरस्टूड? सो इफ आई एम सेइंग Llama 3.1 have 8 billion knobs, that means 8 billion tweak and twister you can do to generate the final output. 8 billion parameter can run on your laptop, but you cannot run 70 billion. It needs GPU. Anybody can tell why? I'm not talking about the quantized version. I'm talking about FP32 or 16. Anybody know quantization? Quantized model? Great.
Quantized model is basically a minimized version of a large LLM, like basically a compressed version.
Great. So I will explain technically in the next slides. Let's bear with me. I'm starting to bore you more and more. Okay, so today we will pick one model and we'll walk with the journey and understand how this model, what parameter is doing throughout the journey. Okay, we'll calculate how it runs on the infra. So you are going to train the 70 million model. Assume yourself today, each and every one, what you require. You require data? Just tell me your requirements. Don't assume I am going to tell you. You assume you are going to train this 70 billion parameter model, and what you need? You need data, right? Enormous data, not data. How much space you need? The memory bill. To train, to save. Think about it. 70 billion parameter is a fixed number that I have given. Everything can be calculated on that parameter number. So start thinking. We will answer. Up going in the slides. How long or how many machines you require? Do the calculations.
140
Yes, you are right. We have some brilliant minds with us today. So let's answer first question. How much data they had used? So I'm taking the real example, not taking any assumptions. This is the Facebook Meta's data. they had taken 15 trillion tokens to train Llama 3.1 model. What do you mean by token?
What?
Yes, what is means by quartz now? 0.75. Value of a word is roughly a token. If we talk about 1000 words, 1000 tokens, that means we are talking 0.750 words almost. That is quartz. Tokens. So token is not just equal to a one word. If we are taking in that way, maybe we are going to save a lot of sequence. We will end up in thousands of words and it's infinite, every day coming new dictionaries. So break down a word is most important thing. That's makes sense as a token. There is a many studies, many different ways. There is another talk I can give another token. So that is as much deep. I will skip it now. You just got the idea, right? And so 15 converts into the multiplied by 0.75, almost 11 trillion words, and this much tokens if you have to study every day. Can you assume how much books you have to read? I have written, if you have read one book a week for 80 years without stopping, you have to about 4,000 books you will read and still it will not finish all the tokens. So that much model have to read every single time then run happens. Now you do the calculations, how much mathematical calculations happens in the behind. So to understand this, you don't require math today's in session, but you require multiplication. If you understand multiplication, you will understand all of these things. Next, you were right. Now I am answering the space, memory problem. How much space you require? So for the 70 billion parameter, you require 2 bytes per each. For the FP16. So not for FP13. FP32, what it means by FP16 and FP32? Okay, so we got some good exciting thing for you. Anyone who answers the difference will get a t-shirt right away. Okay. Should I explain what is the difference between FP16 and FP32? Google करने के बाद भी आपको मैं पूछ लूँगा बैक एंड में ठीक है? Yes, please. Yes, please.
Sir, 16 FP means in 1 second it can show you 16 frames. FPS or FP?
FP, floating point.
Floating point,
What is floating? You are missing the fundamental, guys. Programming fundamental है, integer, floating point numbers. अच्छा C की language में बता दो. Float 16, float 32, floating point number. आप बताओ. हाँ. What it mean and what is the fundamental difference in between? Yes, please again. लग रहा है मुझे फंडामेंटल रिवाइज कराने पड़ेंगे क्या आज? Okay, I will come back to you.
Sir, as I recall, the 16 FP stores 16 bits after the decimal, and the 32 FP stores 32 bits after the decimal.
Halfway correct, but I didn't got the answer what I'm looking for. Okay, so basically let me tell you. See, integer 4, FP16, FP32. FP16 8 bits per byte. It stores, FP16 stores 2 bytes. FP32 will store in 4 bytes. Right? 8 bits in a 1 equal to 1 byte. इतना करेक्ट है? क्या बात है, आज लग रहा है मैं आर्किटेक्चर पढ़ा रहा हूँ, कंप्यूटर आर्किटेक्चर. चलो ठीक है. Okay, cool. Go ahead. So this FP16 having a precision, but also they store in a three-way. One bit is a signed and unsigned. Second, almost 7 bits store the spread of like how much exponential is spreading, and third one is a Mendes, I think, holding the correct value. Right? Yeah, something like that. Now I recall talking with you. This information lost in my mind almost 8 years back. Okay, cool. So next, minor details. जब quantization करते हैं तब हम क्या करते हैं? Let me tell you. When we do the quantization, ये 2 bits जो स्टोर हो रही हैं FP16 में, वहाँ मैंने कन्वर्ट कर देंगे integers 4 में. Then you are storing in a 1 byte almost 4 bytes, means 0.5 instead of multiplying by 2. So roughly आपका 70 million divided into 0.5. 35 जी. Right? Something like that. So काफी डिस्कशन हो गया. Let's go little forward. ये तो मॉडल का वेट था जो मॉडल ट्रेन होने के बाद आया था आपको 140 GB. और हाउ मेनी गाइस, कोई एक आंसर कर सकता है कि जो मैक्सिमम अभी जीपीयू अवेलेबल है उसकी मैक्सिमम वीरैम कितनी होती है जो लेटेस्ट जीपीयू है? 80 GB मैक्स. सामने लिखा हुआ है H100 and S200. S6GB is support memory. Maximum almost 80 GB on a standard NVIDIA GPUs. Yeah, not wrong. Okay, so almost 86, 80, around that memories are available. S100 and S200 have maximum 80 GB. That's it. हमने वेट तो बता दिया कितना वेट लेगा ट्रेन होने के बाद 140 GB. Have you ever imagined कि अगर इसी मॉडल को ट्रेन किया तो कितना लेगा? Same 70 billion parameter model. Not talking about 200 and 400, 5 billion parameter. सिर्फ ग्रेडियंट. देखो इसको एनालॉजी से समझते हैं. You all are a student, you are learning right now, okay, and you are holding 2 bytes of value because you are one person, one byte, one value that is stored in a 2 bytes format, okay. अब तुम्हें एक टीचर भी चाहिए जो तुम्हें ये बताए कि इस गलती पे तुम्हें क्या करना है, लेफ्ट जाना है या राइट जाना है, नॉब को कितना ट्विक करना है. That is gradient. Gradient calculates it, ठीक है. That also takes 2 bytes, 140 GB more. Okay. Next one, who is the coach notebook. एक जो बंदा तुम्हें कोच कर रहा है, जैसे मैं यहाँ पे बताने की कोशिश कर रहा हूँ कि ऐसे से. अब मैं तुम्हारा रिकॉर्ड भी रखना चालू करूँ कि कितना ऑप्टिमाइजेशन तुम कर रहे हो, कितना एवरेज ग्रेडियंट आ रहा है, एंड ऑल्सो टेकिंग द रिसेंट अंडरस्कोर ग्रेडियंट्स, मीन रूट स्क्वायर एरर, ऑल्सो लॉस फंक्शंस. तो और मैं उसका मास्टर रिकॉर्ड भी रखूंगा. दैट बिकम्स 840 GB, 12 bytes मीन्स ये डेटा स्टोर हो रहा है FP32 में, और ये ऐसे ही स्टोर होगा बिकॉज मोस्टली प्रिसीजन ऑप्टिमाइजर को करना होता है कि कितना ट्विक हुआ है ओवर द हिस्ट्री, किस डायरेक्शन में जा रहा है, वो मुझे मास्टर रिकॉर्ड रखना है. सो दैट रिक्वायर 12 bytes each. That becomes 840 GB during the training. You ended up in a 1.1 TB. मॉडल ट्रेन कर, कौन ट्रेन कर सकता है अपने इंफ्रा पे? कोई लैपटॉप पे कर सकता है, फाइन ट्यून कर सकता है, लोरा मॉडल है, पेफ्ट मेथड्स हैं, यू कैन डू दैट स्टिल इन अ क्वांटाइज्ड मैनर, बट इसको you need cloud infra. That's why I was saying this people is also interval that why you need infra. Okay, so let's brainstorm of machines. Why you need it? So basically we will learn now how to train those LLM models, how they get trained. तो आप लोगों को ट्रेन करना है तो आप इन 4 मेथड्स में से कोई भी ले सकते हो. किसी को पता है इन चारों मेथड्स कैसे काम करते हैं? नहीं। देखो, अगर कोई मॉडल ट्रेन हो रहा है, ठीक है, तो सेम क्लास रूम वाली मेथोडोलॉजी देते हैं। मैं एक सिलेबस पढ़ा रहा हूँ, एक क्लास यहाँ पर है, एक बगल में लगी हुई है, ठीक है, सेम सिलेबस, डेटा पैरेलल, सेम डेटा, सेम सिलेबस, आपको पढ़ाया, उधर भी पढ़ाया, ठीक है, दोनों क्लास में, दो टीचर पढ़ा रहे। नाउ टीचर हैव टू सिंक अप कि कितना पढ़ा दिया, सेम सिलेबस है, बट सिलेबस में अलग स्पीड से पढ़ा सकता हूँ, वो अलग स्पीड से, अलग वैल्यूज हो सकते हैं, राइट? तो मुझे सिंक अप करना है, ठीक, तो दैट इज अ डेटा पैरेलल। समझ में आया? टेंसर पैरेलल बहुत बड़ा बोर्ड है, ठीक है, सिंगल। अब उस बोर्ड को मुझे ब्रेक करके आधा बोर्ड उधर भेजना है, आधा इधर, उस बोर्ड को मैं नहीं चेंज कर सकता, वही पढ़ाना है मुझे। That is fixed tensor, you cannot break it, right? So that tensor need to be divided, and now you guys have to sync up. Tensors need to sync up. क्या learn हुआ? Gradients need to be sync up. That is tensor parallel. One लिखा भी हुआ है. One blackboard, two white for the one room, spread across the rooms. Slides देखते रहो. Pipeline parallel. Pipeline parallel का मतलब क्या? 1 से 10 चैप्टर में यहाँ पढ़ा रहा हूँ, 11 से 20 का चैप्टर दूसरे क्लासरूम में पढ़ा रहा हूँ। अगेन यू गाइस हैव टू सिंक अप। एनालॉजी समझ में आई? ग्रेट। स्ट्रेडिंग का क्या मतलब है? किसी के पास कोई सिलेबस नहीं है, एक स्लाइड मेरे पास है, एक उसके पास है, नाउ एवरी टाइम हैव टू सिंक अप, मेमोरी ऑप्टिमाइज करनी है। सो दीज आर द मेथड्स, और मोस्ट ड्रामेटिक वन इज द स्ट्रेडिंग, ठीक है। हाउ दिस डेटा ट्रेन। सो अब जो सिलेबस में बात कर रहा था, आप डेटा और टेंसर्स की बात करो। तो जब आप बात करते हो पैरेलल पाइपलाइंस की, तब आप बात कर रहे हो कि जैसे एक टेंसर एक मशीन पे रन कर सकता है, आपको लिए ग्रुप ऑफ मशीन्स चाहिए होंगी पाइपलाइन को पैरेलल करने के लिए, और ग्रुप्स ये चाहिए होंगे डेटा को पैरेलल करने के लिए। नाउ यू रिक्वायर दिस काइंड ऑफ इंफ्रा। थोड़ा सा बोरिंग हो गया, राइट? नींद आ रही है? अरे बताओ तो। I tried to make you understand. Now let's see some kind of industries who have tried and kind of a shocking moments. Can you see? ये Llama 3.1 405 billion model कितने GPUs पे ट्रेन हुआ है? This is the official record. I'm not giving any input from my side. 16,384 H100 GPUs. That was the latest GPU model by NVIDIA at that time when the model 3.1 is trained. Now S200 is also there. It took 54 days with this much GPU. 15 trillion tokens we already discussed. 39.3 million GPU hours it took to train that model. कुछ आइडिया लग रहा है कि ये नंबर क्या है? अगर इसको कन्वर्ट करोगे तो एक जीपीयू अगर ट्रेन करेगा ना, तो उसको 4,500 साल लगेंगे एक लामा 3.1 मॉडल को ट्रेन करने के लिए। That much infra was required to train this model. And this cluster done in a 54 GPUs. आसानी से हो गया, कर लिया होगा आसानी। अरे कोई मिस्टेक ही नहीं है, सब कैलकुलेट हो गया, बेटा है। ऐसा कुछ नहीं, सब तुम्हारे जैसे इंजीनियर्स हैं, दे हैव टू अंडरस्टैंड हाउ टू डू दीज थिंग्स। आज मैं बता रहा हूँ, आप ये सारी चीज़ें लर्न करके मे बी यू कैन एंड अप इन अ क्लाउड और एंथ्रोपिक और चैट जीपीटीज इंफ्रा टीम। You have to understand this thing. These are the key features. AI infra engineers सबसे scarce demand है, sorry सबसे ज़्यादा डिमांड, but very scarce availability. इसके साथ आपको AI भी समझनी पड़ती है, because how you will decide कि this model को इतने पैरामीटर इतने पे रन करना है. So this is the key factors that I'm letting you. 3 साल पुराना टॉपिक, 3 साल पहले बताना था, अभी आप पीछे हो गए. Learn it as soon as possible you can. Problems आएगी, ऐसा नहीं है, सब कुछ अच्छा नहीं है. GPU was getting so hot. Every day they are praying कि सब कुछ अच्छा चलना चाहिए, कुछ फेल नहीं होना चाहिए. But who were failures? What failures was there? 419 interruptions in a 54 days of training. GPU खराब हुए, 140 GPUs खराब हो गए, उनके पास काइंड ऑफ डेटा इंटरप्शन एरर्स, पाइपलाइन एरर्स। सर्वाइवल ट्रिक सिर्फ एक थी, आप मॉडल ट्रेन कर रहे हो, जो आप अपने लैपटॉप पे भी करोगे, क्वांटाइज मॉडल के साथ सेम ट्रिक आपको भी यूज करनी है। You have to check points, you have to say. It's not about this transformer LLM model. I'm telling about any deep learning model you are going to train. It will train in a same strategy. You have to check points, you have to store the value and restart if you get stuck or your machine got interrupted, you got network failure, or you are training with us free resources. जैसे कैगल पे आप ट्रेन कर रहे हो या फिर आप नोटबुक पे ट्रेन कर रहे हो, क्या नाम है उसका, कोलैब, ठीक है, तो वहाँ पे आपको चेक पॉइंट बनाते रहो, ट्रेन करते रहो जब तक फ्री ट्रेन मिलता है। यू कैन ट्रेन इन अ फ्री। किसने बोला कि आपको चाहिए इंफ्रा आपके उनके लैपटॉप पे? आई एम टेलिंग द स्केल यू कैन ऑप्टिमाइज, लर्न अबाउट और अंडरस्टैंड हाउ मच मैथमेटिक्स और कैलकुलेशन इज रिक्वायर्ड। आप घर पे जाके 3 बिलियन पैरामीटर का एक लामा मॉडल उठाओ, ठीक है, उसका क्वांटाइज वर्जन लो आपके और उसको पैक्ट मेथड, पैरामीटर एफिशिएंट फाइन ट्यूनिंग मेथड, उसके थ्रू आप उसको ट्रेन करो। इसमें क्या होगा, आपका बीच का लेयर वेट्स, इट डजंट हैव टू कैलकुलेट एवरीथिंग। आप जो आप लेयर ट्रेन करना चाहते हो, आप अपने किसी फेवरेट सब्जेक्ट पे ट्रेन कर दो, फेवरेट टॉपिक, फेवरेट प्रॉब्लम पे ट्रेन कर दो, इट विल स्टार्ट गिविंग यू रिस्पॉन्सेस। एक्यूरेसी थोड़ा अप डाउन होगी, दैट इज फाइन, बट आप ऑलरेडी एक ट्रेन वेट उठा रहे हो, दैट इज ऑलरेडी ट्रेन ऑन दैट 16,000 GPU क्लस्टर, सो इट विल हेल्प यू आउट। ट्राई करो, you will get to understand कि क्या क्या चीजें आप सीख सकते हो इससे। You will understand कि how how LLM works on GPU, how works on your machine. आप अपने CPU पे भी चला सकते हो। Nowadays some models are there. आप edge devices पे चला सकते हो, फोन पे। These models are available, but they are highly quantized versions. थोड़ा बहुत accuracy के साथ जोड़जाल होता है, you have to accept it. But suppose this whole model running on that much infra and also running on your system, private LLM, बढ़िया उसके साथ chit chat करेंगे, private conversation रखेंगे about office and all, कुछ उल्टा नहीं सोचना। Okay, cool. Oh, already this exercise is there. So same thing I was telling without the PPT. Now you can read the steps. ट्रेनिंग खत्म, आपके पास 70 बिलियन का अगर मॉडल ट्रेन किया तो यू विल एंड अप विद ओनली 140 GB फाइल, ठीक है, सर रफली अराउंड दैट। कॉन्फ़िगरेशंस भी होती हैं वगैरह, बाकी चीज़ें भी, मॉडल वेट्स एंड मैपिंग भी होती है, दैट्स व्हाई इट बिकम्स दिस मच 140 GB। सो यू कैन यूज इट। आधी स्लाइड हो गई, कांग्रेचुलेशन गाइस। आगे की स्लाइड देनी ही नहीं देनी। देखो स्टैमिना कैपेसिटी हो तो दो, या फिर आएंगे। How many of you in favor? Next slides will be finished in 10 minutes only. मतलब 10 मिनट ब्रेक। ओके, मेरी आवाज नहीं पहुंच रही ना लास्ट तक, वो इसलिए हाथ नहीं उठ रहे, मुझे पता नहीं चला। Okay, cool. So this is now fast forward. That was the important part to understand, because I want to make you understand whenever you use the LLM. Now it's a fast forward thing to make you go through the how things are better. So this is briefing. Briefing का मतलब क्या होगा कि आप अपना पूरा क्वेश्चन जो प्रॉम्प्ट दे रहे हो वो एक बार में LLM ने रीड कर लिया, इट गॉन थ्रू द ऑल द टोकन्स, वो जो 70 बिलियन पैरामीटर्स हैं वो सारे इसको डिकोड करेंगे विद अटेंशन। तो जो भी फाइल बनेगी वो 320 KB की बनेगी। दैट इज योर होमवर्क कि कैसे बनेगी वो 320 KB की। दैट आई एम नॉट गोइंग टू कवर टुडे। And writes one word at a time, that I already told, वो sequentially ही predict करता है। So when question is loaded and coming the first token to your chat window, कि अब response start हुआ, ठीक है, that starts write one word at a time, वो word आपको मिला, ठीक है, predicted word, 320 KB, that I done। अब ये आपको calculate करना है कि कैसे हुआ। 70 billion parameters हैं, it's your homework. Okay, so roughly it will end up with the like 4,000 word conversation जो आपने throughout the chat की, that will end up in a 1.3 GB memory. And if 100 people are doing the same conversation, 130 GB, एक डिवाइस पे तो हो ही नहीं सकता, करेक्ट? 80 GB limit है. You need infra that scales over the multiple thousand GPUs. The node for 100 chatting users are now heavier than 450. One more bigger problem. आप स्पीड नहीं बढ़ा सकते. There is formula. मेमोरी की स्पीड ऑलमोस्ट 320 kbs per second something like is there. कि NVIDIA यूज करता है ना, उसका 3.3 ट्रिलियन और बिलियन tokens per second ऐसा कुछ है. And model size is 140-70 million. Divide करो, almost you will get the 24 words per second. This much words or almost tokens multiplied. So now you got it, right? ये स्पीड नहीं तोड़ सकते. आपको उतने ही टाइम में रिस्पॉन्स मिलेगा. This is also you have to figure out. कैसे? I'm leaving you guys with the questions because you have to explore and understand. I'm giving the facts. This is fact related to why GPU is not required, because speed you can't increase. एक जो नेटवर्क ये AI की प्रॉब्लम नहीं, ये इंफ्रा की प्रॉब्लम है. इंफ्रा आपका एनवीडिया उतना ज़्यादा सपोर्ट ही नहीं करता. आप उससे ज़्यादा स्पीड में ट्रांसफर ही नहीं कर सकते डेटा. एंड डिवाइडेड बाई मॉडल साइज. मॉडल के भी पैरामीटर्स अपने, जितना बड़ा मॉडल जितने बड़े पैरामीटर स्पीड और घटेगी, मतलब उतना ही कैलकुलेशन करना है, उतने ही टेंसर्स को आपके पर टोकन जो आपने वर्ड भेजा है ना क्वेरी में, उससे मल्टीप्लाई करना है. सो अभी मेमोरी के लिए फाइट चल रही है. ओके, बहुत कम समझ में आया होगा, बट दिस इज द क्रक्स. ओके, सो सॉल्यूशन क्या है? एक बंदा ही चैट कम्युनिकेट कर रहा है ना इतने सारे से. सॉल्यूशन क्या होगा? सॉल्यूशन होगा कंटिन्यूअस बैचिंग. एक रेस्टोरेंट जहां पर लोगों के पूरी तरह से टेबल से उठने का वेट ना करके एक बंदा खा के उठा, दूसरे को तुरंत बैठा दिया. दैट इज कंटिन्यूअस बैचिंग. You are moving, keep moving, and people are coming. जैसे खाना खाया हट गया, दूसरा बंदा बैठ गया. That is continuous batching. मतलब हमारा मॉडल में एक रिस्पांस आया, एक यूजर का रिस्पांस गया, दूसरे का तुरंत शेड्यूल कर दिया. That is स्मार्ट शेड्यूलिंग इज आल्सो देयर. पेज्ड अटेंशन का मतलब एक नोटबुक के अंदर आप पूरे डेटा का मतलब एक सिंपल आपने एक पर्सन ने क्वेरी की, उसका पूरा रिकॉर्ड एक नोटबुक में नहीं करना है, एक पेज पे करना है उस नोटबुक की. मतलब उतनी थाउजेंड्स ऑफ नोटबुक नहीं मेंटेन करने का, थाउजेंड्स ऑफ यूजर है. वी जस्ट हैव टू मेंटेन पेजेस. सो दैट इज दिस इज अ वेरी ओल्ड कॉन्सेप्ट. किसी ने ओएस पढ़ा है, ऑपरेटिंग सिस्टम, मेमोरी पेज अटेंशन मैनेजमेंट सिस्टम है ना उधर? हाँ, पढ़ा होगा कभी. सेम कॉन्सेप्ट, बस एआई ने फॉलो कर लिया. ओके, क्वांटाइजेशन आई ऑलरेडी एक्सप्लेन. एक क्या लगता है जो वेब एप्लीकेशन MBs में होती है वो लोड होती है, और मॉडल लोड होने में कितना टाइम लगेगा? It takes almost 10 to 12 minutes only 17 GB मॉडल लोड करने में. फिर उसको वार्म अप भी करना होता है. वार्म अप का मतलब क्या होगा? हेल्थ चेक करनी है, सारे एंड पॉइंट्स चेक करने हैं, लॉग्स चेक करने हैं, सब कुछ करेक्ट है. दैट इज वार्म अप. आपको वार्म अप करके रखना पड़ता है. सो अब सोचो, GPU जब OpenAI या क्लाउड से आप कम्युनिकेट कर रहे हो, रियल टाइम में वो कितनी स्केलिंग, डिस्केलिंग, वार्म अप्स कर रहे होंगे. नाउ यू कैन अज्यूम. ओके, हाँ, ऑलमोस्ट 3 स्लाइड्स मोर जो आपके काम की. 2 मिनट्स सबको पता है, अभी इतनी बार एक्सप्लेन किया. सो एवरीबडी नो व्हाट्स डॉकर. डॉकर क्या करता है? जो आपकी मशीन पे काम कर रहा है, ठीक है, अगर वो मैं सबमिट करूं प्रोडक्शन में और कोई लाइब्रेरी में अपडेट हो गई, वो कटेगा. तो इससे अच्छा मैं आपकी मशीन को ही प्रोडक्शन में डाल दूं. दैट इज डॉकर. आपकी मशीन की कंप्लीट कॉपी, दैट इज डॉकर, गोज टू द प्रोडक्शन. एंड दैट वन कॉपी को अलाइव रखता है कुबरनेट्स, दैट इज पॉड, एक नोड. एंड n number of nodes required to support n number of traffics. Depends. आपकी अगर एप्लीकेशन 100 लोगों को सपोर्ट कर सकते हैं, then you require 1000 के लिए 10. Clear? Okay. So only some machines have अब Kubernetes यार काम वैसे ही करता है लगभग जैसा बाकी एप्लीकेशन है मेमोरी के लिए करता है, but it requires not memory, now GPUs. It demands मेरे को 12 GPU और चाहिए. Customer 1000 customers की request आ रही है extra. Same way it demands, just like memory demands, I need 20 GB more. Similarly. New copies, new pods में take time तो warm up करके रखना पड़ता है. किसी भी प्रोडक्शन इन्वायरमेंट में काम करोगे सिमिलर वे में काम करता है. अगर आपके पास मल्टीपल टीम्स हैं, मल्टीपल जीपीयूज हैं, यू हैव टू मेक द क्लस्टर्स एंड दैट विल नीड टू बी वर्क. ठीक. एवरी प्रॉब्लम वाज टुडे इज अबाउट क्लाउड और इंफ्रा प्रॉब्लम. I haven't teach you AI. I taught you how these LLMs works on the cloud or infra. So 1.1 TB does not fit any single machine. It need to split work across the GPUs and tasks. A GPU fails every 3 hours or 4 hours. You need to make another GPU or as a backup to make up and refresh that. आपका सिस्टम हैंग होता है, क्या करते हो? रिफ्रेश करते हो, रिस्टार्ट करते हो ना. सेम कुबरनेटिस पॉड को रिफ्रेश किया, रिस्टार्ट करें, नई कॉन्फ़िगरेशंस लोड की. सेम मॉडल मेनी मशीन्स आपकी एक ही मॉडल सेम वे में बिहेव करना चाहिए हर जगह. डॉकर रिक्वायर्ड है उसी तरीके से. पता चले एक मॉडल की कॉन्फ़िगरेशन अलग है, दूसरे की अलग, रेप्लिका शुड बी आइडेंटिकल, राइट? दैट हैंडल्स बाय कुबरनेटिस. few GPUs, many things, and slows and broken, measure everything. भाई मेजर तो करना पड़ेगा. I've written like open telemetry and Prometheus is required to measure, or there are like n number of things to measure, n number of tasks. अगर आपको agents को monitor करना है, तो you need different, not maybe Prometheus is just for observing your application, but Langfuse can observe your agents. Okay, so yeah. You can read, right? कौन क्या यूज करता है? Llama is using H100 cluster. They are using also Kubernetes. ChatGPT is using Azure and K8s environment. In the backend kind of Kubernetes cluster, they use 7,500 nodes. Gemini is using Brog structure. सुना है? अगर आपने Kubernetes सुना है, Brog नहीं सुना है. Anyone can answer? आप बता सकते हो? Brog और Kubernetes के बीच का रिलेशन. Brog गूगल का प्रोजेक्ट है, Kubernetes उसका ओपन सोर्स प्रोजेक्ट है. It's a subsidiary only. That's the relation. Parent and child. Okay. And Claude using Titanium to TPUs also for and a combination of GPUs, TPUs and borrowed from NVIDIA. So they use this infra. Okay. This is the last slide. Everyone knows आपको किस तरह से यूज करना है. आप API कॉल करोगे तो you are using taxi. For that call only. Manage cloud endpoints. जहाँ पर आप Bedrock, Vertex अगर यूज कर रहे हो तो that is a one person is sharing each and everything, managing in models from your side. GPU आप रेंटली ले सकते हो, जैसे So, self-hosted Kubernetes, and that's today's. अब मैं आपसे कुछ तो पूछ सकता हूँ. काफी देर मैंने कुछ बताया. And who will respond will get T-shirt. Yes. Okay, so the question is coming. Suspense. Anthropic is using what infra? Raise your hand. Is it Titanium?